Sir, we are having one of the chief guests, Dr. Samson Matthew, sir, and Professor Shenian, sir, as General Conference Chair, and Dr. Murthy, sir, co-chair.
Yeah, good morning to you all. Good morning to you all, sir.
Good morning, Radhakrishnan, sir. Good morning. I'm Samson.
Sir, with all your permission, can we start the program, sir?
Please, sir. Please.
Yeah, thank you, sir. Yeah, Pujita Lakshmi and Sri Sai Krishna, please.
Yes, sir.
Yes, sir.
Yes, sir, we are proceeding, sir. Success is not the key to happiness. Happiness is the key to success. If you love what you're doing, you'll be successful. A very warm good morning to Galaxy of Intellectuals, invited guests, professors, students, and ladies and gentlemen. I, Pujita Lakshmi of 3rd Civil.
I, Sri Sai Krishna of 3rd Civil, take this as a privilege to warmly welcome you all on the first day of 2nd International Conference on Sustainable Construction Technologies and Advancements in Civil Engineering, organized by the Department of Civil Engineering, Sri Vishnu Engineering College for Women, Bhimavaram, in collaboration with Indian Concrete Institute Student Chapter.
A day without prayer is a day without blessing, and a life without prayer is a life without power. So let's begin this program by seeking the blessings of Lord Almighty with a prayer song. Now, I request Miss Akila to grace the occasion with a prayer song.
मुदाकरार्थमोदकं सदा विमुक्तिसाधकं कलाधरावतंसकं विलासिलोकरक्षकम् अनायकैकनायकं विनाशिते भदैत्यकं नाथासुभासुनायकं नमामि तं विनायकम् जय गणेश जय गणेश जय गणेश पाहि माम् जय गणेश जय गणेश जय गणेश रक्ष माम् जय गणेश जय गणेश जय गणेश पाहि माम् जय गणेश जय गणेश जय गणेश रक्ष माम् न ते तरातिभीकरं नवोदितार्कभास्वरं न मत्सुरारिनिर्झरं न ताधिकापदुद्धरं सुरेश्वरं निधीश्वरं गजेश्वरं गणेश्वरं माहेश्वरं तमाश्रये परात्परं निरन्तरम् जय गणेश जय गणेश जय गणेश पाहि माम् जय गणेश जय गणेश जय गणेश रक्ष माम् जय गणेश जय गणेश जय गणेश पाहि माम् जय गणेश जय गणेश जय गणेश रक्ष माम् समस्तलोकशङ्करं निरस्तदैत्यकुञ्जरं दरेतरोदरं वरं वरेफमत्रमक्षरं कृपाकरं क्षमाकरं उदाकरं यशस्करं मनस्करं नमस्कृतां नमस्करोमि भास्वरम् जय गणेश जय गणेश जय गणेश पाहि माम् जय गणेश जय गणेश जय गणेश रक्ष माम् जय गणेश जय गणेश जय गणेश पाहि माम् जय गणेश जय गणेश जय गणेश रक्ष माम् जय गणेश रक्ष माम् जय गणेश रक्ष माम् Thank you, one and all. Thank you, Akila. That's an auspicious start. I am excited and also feel blessed about this role as the 2nd International Conference on Sustainable Construction Technologies and Advancements in Civil Engineering is built with an intent of active and interactive learning. Sri Vishnu Engineering College for Women was established during the academic year 2001 to 2002 to empower women in professional courses. This institute has witnessed significant growth within 19 years and stands out as one of the best engineering colleges in Andhra Pradesh. This institute is secreted by NAC with A grade. This institution is under autonomous status from the academic year 2014 and it is the first women's college under JNTUK to get such an autonomous status. In recognition of its progressive strides, the World Bank has granted TechWhip Phase 2 project to SVECW. Indian Merchants Chamber recognized the service of SPECW with its Ramakrishna Bajaj National Quality Award in the education sector.
The Department of Civil Engineering SVCW was established in the academic year 2009 to 2010 with an annual intake of 60. The department is accredited by NBA under Tier 2. The Department of Civil Engineering received the project from the Department of Science and Technology, New Delhi, worth of Rs 60 lakhs for the construction of 3 NOS sewage treatment plants in the SVCW campus to treat the wastewater. The treated wastewater is utilized for various purposes and also serves the Bhimavaram town. The department has good strength of specialized persons from structural, geotechnical, water resources, transportation, and geoinformatics. The department periodically organizes seminars, symposia, workshops, and guest lectures for the benefit of both students and the faculty. Also, the department has won ICI Ultratech Concrete Day and the Construction Excellence Award 2020 in the category of Outstanding Student Chapter of Andhra Pradesh for the year 2020. Apart from the regular academics and activities, students are motivated and encouraged towards research works and conferences under the guidance of the HOD, who has won World Research Council International Best Researcher Award of the year 2020 in the area of terra mechanics and nanomaterial in payments. The department has an excellent blend and young and justful HOD with well experienced and diligent faculty.
The second International Conference on Sustainable Construction Technologies and Advancements in Civil Engineering, ScTACE 2021, aims to provide collaborative opportunities for researchers, leading academic scientists, research scholars, and industrial practitioners in which the latest research and practice in sustainable construction technologies and advancements in civil engineering emphasis on structures, transportation, geotechnical, environmental, remote sensing, and so on are shared, discussed, and promoted. ScTACE 2021 will encourage interdisciplinary and welcome contributions that span the engineering and allow researchers and good practitioners to exchange ideas on the latest developments in sustainable construction technologies and advances in civil engineering. Therefore, ScTACE cordially welcome you all to be part of the international conference and join hands in extending the professionalism with sustainability in civil engineering.
Before starting the session, let me show our sincere gratitude to those who supported for ScTACE 2021. Sincere thanks to KV Vishnuraju Garu, Chairman of Vishnu Society. Sincere thanks to Ravichandra Rajgopal Garu, Vice Chairman of Sri Vishnu Educational Society, and Aditya Vizam Garu, Secretary of Sri Vishnu Educational Society. Their ideas of student centricity have ushered in several developments towards motivating force in steering and expanding the horizons of foundation and society towards excellence in all its academic and professional endeavor and strengthening students' employability, sports spirit, achievements, and among many other noteworthy laurels to be mentioned here.
Sincere thanks to Dr. G. Srinivas Rao, the principal of Sri Vishnu Engineering College for Women. Dr. G. Srinivas Rao has received his PhD in Mechanical Engineering from Vishwesvaraya Technological University, Belgaum, Karnataka, and has over 29 years of teaching experience. Dr. G. Srinivas Rao is a life member of professional bodies like ISTE, CSI, and SAE. As a researcher, he published a good number of technical papers in national and international journals. He guided MTech students in the area of CAD and CAM and more than 60 students at UG level. He completed postgraduate diploma in advanced studies in software export technology in the process of updating his knowledge. Later, to fit into the quality of system, he completed a course and became the certified examiner for quality management of Indian Merchants Chamber Quality Award. Thank you, sir, for your support. Also, we would like to thank Dr. P. Srinivas Raju, the Vice Principal of Sri Vishnu Engineering College for Women. P. Srinivas Raju received his PhD in Mechanical Engineering from Rayalaseema University, Kurnool. He has been rendering his services to this institution since inception, right from the birth of SVCW. He has put all his sincere efforts and played a key role in its development activities. Dr. P. Srinivas Raju is a life member of professional bodies like IEE, SAE, and CSI. He has over 19 years of experience in teaching. As a researcher, he had published various technical papers in international journals of repute and attended various international and national conferences. Thank you, sir, for your constant support.
During the session, let me introduce the General Conference Chair of ScTACE 2021, Professor Shen Chen. Professor Shen obtained his bachelor's degree in 1989 and a master's in geotechnical engineering from West Virginia University in the year 1992. He had completed his PhD in structural engineering from West Virginia University in 1996. Professor Chen worked as a faculty in the University of Alabama at Birmingham and is currently working as a professor in the Department of Civil and Environmental Engineering at UNC Charlotte. He is a recipient of the 2007 Trekvip Visiting Professor at NIT Trichy and was honored with Fulbright Nehru Academic and Professor Excellence Award at NIT Trichy in 2014. He also served as the international faculty for the Indian National Global Initiative for Academic Networks sponsored by the Ministry of Human Resource Development, Government of India in 2019. Also, Professor Chen was operated as the chief of the ASCE reconnaissance team and led to the Philippines for post-Super Typhoon Haiyan assessment. He also worked as the project head of a National Science Foundation project in assessing the impacts of Hurricane Maria on the power grid in Puerto Rico. Professor Chen is specialized in laser-based and non-contact sensing techniques, and his research projects are funded by the U.S. Department of Energy, the U.S. Army, the U.S. Department of Transportation, NSF, EPRI, Power Industries, and local dots. He is an active member of ASCE Forensic Engineering Division and is former chair of the Committee on Forensic Investigation. His research interests are in the areas of power transmission structures, carbon storage in geological formations, remote sensing for bridge monitoring, forensic investigation, and condition monitoring, especially after hurricane disasters. Professor Chen blazoned Capier's publications and is well-renowned speaker in several programs and institutions. And now I extend a warm welcome to our General Conference Chair of ScTACE 2021, Professor Shen and Chen, to mark the meet with his words of wisdom.
Thank you very much for the introduction. Good morning, Andra, and everywhere else. I would like to extend a appreciation to this special event hosted by the Sri Vishnu Engineering College for Women. And despite the challenges posed by this pandemic, this conference has gone virtual, and this can only be done by willpower and hard working of the conference organizers and conference participants. So I really like to encourage everyone to applaud the efforts from the leaderships of the college, and also Dr. Palaguma, the conference chair, and his team of hardworking students. On the subject of overcoming challenges by the conference, I want to really emphasize that this is the pandemic time, and all of us have suffered loss and challenges, including many of us have to work from home and being isolated. But despite all this, I want to thank Dr. Kumar and his team for organizing this event. And to put things in perspective, for many of us, this global pandemic is probably the single most important global event in our lifetime. As of August 2021, the pandemic has caused more than 4 million deaths worldwide. While we are still uncertain of the future, we know that in our hearts and souls that we will continue to work hard within our own capacities. Hence, let us applaud our colleagues and ourselves for being selfless and willing to continue to push technology advancements for better living conditions for mankind. And this is why we suffer our personal losses and difficulties to continue our work despite the challenging time. We are really living in a very unprecedented moment in human history. We witness disasters brought about by climate change, including extreme hurricanes, ice storms, tornadoes, forest fires, and earthquakes. These are natural events that are reducing the service capacities that many archaic infrastructures and putting human lives at risk. These events challenge us to think out-of-the-box solutions and extraordinary ways to manage our built environment. And also, at the same time, we witnessed 2 civilian teams travel to the outer space. One that's happening this morning. And this is something that our parents, grandparents, and great-great-great-grandparents would never have imagined possible. Okay, this mix of natural and geopolitical turmoil and surpassing scientific accomplishments annotate a very unique time in human history. And we are here designing and building an infrastructure that can withstand the test of time and to protect against natural and man-made disasters. The significance of our work will only be revealed in time to come, not too distant into the future. And so let us carry this burden of professional and civic responsibilities as civil engineers into the future. And we do want to remember our colleagues in the civil engineering field who have passed away during the pandemic. Here, I'd like to remember Professor Chidambaram Natarajan from the National Institute of Technology at Trichy in Tamil Nadu, who is my best friend and a very dear Anna to me. Professor Sien is a very well-recognized structural engineer in southern India. He passed away in January of this year due to non-COVID related illness, and his loss is still felt by many of his students and colleagues who wrote to me and expressed their sadness. However, we should not grieve over the loss of so many creative minds in our community. We need to strive to make our profession better in serving our societies. And for the younger generation, engineers and students, regretfully that we cannot meet in person during this year's conference. But please do stay and listen to all the nice presentations in this two-day event. My wish is that the conference will continue for many years to come, and the civil engineering community will back this conference and continue to participate in this event. And finally, I want to thank Dr. Kumar again, and please enjoy the conference. Thank you.
Thank you. Thank you very much.
Thank you so much, sir, for such splendid words, and we are fortunate to have you here with us. Moving ahead, I take privilege to introduce Dr. Narasimha Murthy, the General Conference Co-Chair of ScTACE 2021. Dr. Narasimha Murthy is a registered professional traffic engineer in California, USA. He has obtained his Doctor of Philosophy in Transportation Engineering from Concordia University, Montreal, Canada. He is an expert in the area of air quality management, certified from the University of Irvine, California, and also acquired a verified certification of Employee Transportation Coordinator from the Southern California Air Quality Management District. Dr. Murthy is in transportation for over tenure of 35 years and now is appreciated for his contribution to some superlative projects in the area of transportation planning, traffic engineering, urban planning, freight planning, transit planning, traffic simulation, travel demand forecasting, and intelligent transportation systems. Dr. Murthy worked as a consultant in the private sector and public agency concerning the LA Metro project. He started his own consultancy in 2006, marked as Murthy Transportation Consultants Incorporated, and worked on several noteworthy projects. Also, he was honored by the Transportation Research Board to assist research projects on the Highway Capacity Manual and development of the Unsignalized Intersection Guidebook by the National Council for Highway Research. Dr. Murthy accompanied the director of the Federal Transit Authority, Mr. James Simpson, in presenting their work on BRT at Hyderabad. He aided the Los Angeles Public Health Department in improving 2 chapters for the Model Street Design Manual. Dr. Murthy has more than 25 publications in the field of transportation. He co-authored a titled Text Transportation Engineering Basics 2nd edition, published by the American Society of Civil Engineers. Besides all the technical aspects, Dr. Murthy prized for his social work and his rightful thought of establishing driver education and enlightenment program, which is remarkable. He is currently in association with Dr. Pala Girish Kumar, founder of ScTACE, with a prime vision to drive the society towards a self-disciplined routine concerning road safety as a crucial aspect and students as the prime movers, so as to instigate well-disciplined and responsible future generations. Dr. Murthy showered a great deal of assistance to the students of the Department of Civil Engineering, SVCW, and has been a motivator all the times. With this short introduction, I request Dr. Narasimha Murthy, the General Conference Co-Chair of ScTACE 2021, to share his valuable insights with the audience.
Thank you so much. I really appreciate it. And good morning to everyone, and good morning to the chair, Dr. Matthew, Dr. Engineer Radhakrishnan, and Professor Chen, and Dr. Paula, the conference chair, and all the students, and all those who are putting their time and effort to make this happen, as Professor Chen clearly explained that this is a time where it's unprecedented, as he said, and it's a challenge to everyone, whether it's a baby or a youth or an old person. It's been a challenge to live through this, and it's a coincidence that today is October 13th. If anybody remembers, it's exactly 2 years back. Something in the news started leaking from China. Whether it's China or the other place, doesn't matter. It's just a planet from where this particular news started coming out. It's a coincidence that it is 30th, but also it's a coincidence after hearing the inaugural the God's recital that was done. Today happens to be we are traditional Navratri is going on in India, and today happens to be Saraswati Puja. It is one of those great days when Saraswati is being brought in a virtual way to share our knowledge with everyone. So let God bless everyone who is present here and also not present to have a wonderful year and also free from COVID. And hopefully, I am keeping my fingers crossed. Hopefully, like Professor Chen said, we all will be able to meet personally and share our thoughts and also be with all of you at the engineering college premises. So that's one of my hope. But one thing I want to tell all the students of civil engineering, you should be extremely, extremely proud of your profession. This is the oldest and the first engineering field anywhere in the world. You go through the history of the world. Go through the history of the world. You won't find mechanical, you won't find electrical, you won't find other engineering. They all evolved after civil engineering. Anything, any engineering field that is out there, what do they need? They need a roof. Who provides the roof? Us, the civil engineers. Apple can build the biggest premises in the world, but who is it that designed it? Civil engineers. So remember that civil engineering is so important. Also, civil engineering, you should be very proud of it because we provide everyday things that people need, like the roads, like the bridges, okay, so many, and the buildings, and everything you can think of, including every house, the sewer systems that we build. Imagine a day when the sewer system is blocked or not designed the way it's supposed to be designed. The whole city, you know what will happen to it. So we are, as civil engineers, provide all the basic services that the humanity needs for living. So we should be extremely proud of it. And we should continue to improve it. For example, if I talk about being in California, it may be surprising for you to hear that we have about 150 to 200 earthquakes from the point of 1 to 3.3 Richter scale earthquakes every day. But how is this whole state sustaining that without any much damage? Because the way things are there, and also like Professor Chen, the people who are experts in their area try to provide the necessary solutions from the point of civil engineering to build buildings, bridges, roads, etc., in such a way that they can take the seismic loads. So civil engineering, basically, you should always be proud of it. That's all I'm trying to drive today is we talk about sustainability in civil engineering here. Sustainability comes from this also, that is saving lives. How do we make things good for people living? So all these things come under civil engineering. So whether you're in transportation, whether you go to tomorrow to geology, or whether you go to soil mechanics, or whether you go to hydraulics or fluid mechanics, let me just give a simple example of fluid mechanics. It comes under civil engineering and mechanical engineering, but the need for fluid mechanics is so important in all the things that are done. And also think about the greatest civil engineer that we had in the South, Dr. Sir M. Visvesvaraya. It was his very recently, it was his birthday also, and we had the engineering day in India. So you have to reflect back to those people who achieved in our field, and also we should look forward to what we can do that can make the society a better place. With that, I will end my talk but the more important, be proud to be a civil engineer, and doesn't matter which field you are in civil engineering, you will be contributing to the society. And enjoy this conference. It's very important that, as I said, today is Saraswati Puja Day, and it's a good day to start sharing the knowledge across all kinds of different fields in civil engineering itself. Okay, so have a wonderful day. And with that, I end my speech. Thank you so much for giving me this opportunity, and also the great pleasure to meet all of you virtually. But I keep my fingers crossed to meet you all next year in person. Thank you.
Thank you, sir.
Thank you, sir, for such remarkable words, and we are grateful to you for your support and encouragement at times. I
Thank
would like to take this as a privilege to extend a special welcome to Dr. Pala Girish Kumar Garu, the convener and conference chair of ScTACE 2021. Dr. Pala Girish Kumar has obtained his master's in transportation engineering and management from National Institute of Technology, Tiruchirappalli in 2014 and PhD in civil engineering from National Institute of Technology in 2018. He started his career as an assistant professor at GEC and currently working as a head and associate professor at Sri Vishnu Engineering College for Women Autonomous since 2019. At a very adolescent age, he has been delegated as the head of the Department of Civil Engineering at SVECW. Dr. Pala is the prime mover and instigator of Royal Civil Colloquium, established in the year 2019, whose cardinal motto is to expose women students to the technical and industrial aspects of working areas. Dr. Pala was the founder of Career Development Program in SPECW that functions in indulging technical and non-technical skills. He also reinstated the Indian Concrete Institute Student Chapter in SPECW and wrapped the Outstanding Student Chapter of Andhra Pradesh 2020 award from ICI Ultratech. In addition to the initiatives taken, Dr. Pala established a new association on 21st April 2021 called SWEC Engineers Association of Road Safety and Awareness, aiming to create road safety and driver awareness among students of school and college level. He holds a lifetime membership in professional bodies like the Indian Geotechnical Society and Institution of Engineers India. He was honored with the National Award from the Government of Tamil Nadu for the best project during the year 2014, Best Paper Award received for the paper presented in International Conference NIT Tirchi, and also won the International Best Researcher Award of the year 2020 in the area of Terra Mechanics and Nanomaterials in Pavements from IDMAS Learning Center, Malaysia and World Research Council. Apart from being an active facilitator, he holds the stance as National Advisory Committee member of the International Conference on Advancements and Innovations in Civil Engineering. Dr. Pala was induced as the editorial board member of Journal of Review in Science and Engineering and also a reviewer of the Transportation Research Board, International Journal of Engineering Sciences, Advanced Computing and Biotechnology, Global Journal of Research in Engineering, USA, Silicon Journal, and two more journals. Besides all, Dr. Bala is the ambassador of Procedia, the conference managing system, and presenting India. He has blazoned 18 publications at international conferences, 15 plus at national conferences, 30 plus publications in well-reputed international and national journals, and a monograph titled Speed Detection and Management, an ITS application with Lambert Publishers UK and other two book chapters as well. With this short introduction, I request Dr. Pala Girish Kumar, convener and conference chair of ScTACE 2021, to address the gathering.
Thank you very much, Sri Sai Krishna. To all the eminent speakers and reputed dignitaries, our chairman, sir, Sri K.V. Vishnuraj Garu, and vice chairman, Sri Ravichandran Rajgopal, and secretary Aditya Visam, and honorable principal Dr. G. Srinivas Rao, and vice principal Dr. P. Srinivas Raju, and all respected other departments HODs, and my dear colleague faculty, students, and my dearly beloved audience. It is a glad welcome I bring to you this morning, filled with desires, hope, dreams we all share. Most of you have made an immense effort to join us today on the occasion of the second international conference on sustainable construction technologies and advancements in civil engineering, ScTACE 2021 inaugural. Honoring your support and encouragement in every phase, on behalf of the entire team, I, Dr. Pala Girish Kumar, Head and Associate Professor of the Department of Civil Engineering, SVCW, and Conference Chair of ScTACE 2021, bestow our gratefulness to you all. In addition, I would like to take this opportunity to venerate the chief guest of ScTACE 2021, Dr. Samson Matthew, the Director, NATPAC Kerala, and the Engineer R. Radhakrishnan, Secretary General, Indian Concrete Institute, Chennai. Engineer K.B. Ratnakar Reddy, Managing Director, Infra Support Engineering Consultants Private Limited, and Engineer M.A. Joseph, ICI Chairman, Kochi, Regional Head Technical Services Ultratech Cement Private Limited, Kerala, who have been of exceptional assistance, and I wholeheartedly thank you for accepting our invitation, sir, and joining us in the sequence of the conferences, ScTACE. Also, I extend my sincere thankfulness to the General Conference Chair of ScTACE 2021, Professor Chenians from the University of North Carolina, and General Co-Chair Dr. Narasimha Murthy, sir, the Transportation Engineer and Traffic Engineer Consultant, USA, and the Scientific Committee Chair Professor D. Nagesh Kumar from IIC Bangalore, and Program Committee Chair Dr. Neelima Satyam D from IIT Indore, and Program Committee Co-Chair Mr. Madi from Iran, for being the most radiant aid to the conference team. Just as to add more charm to the conference, the speakers, Professor Krishna Reddy and Dr. Ramesh from the University of Illinois, USA, Professor Srinivas from the University of North Carolina, USA, and Professor Venkatesh from Purdue University, USA, and Professor Eldo TI from IIT Bombay, Professor B. Krishna Prapurna from IIT Tirupati, Professor KVL Subramaniam from IIT Hyderabad, and Professor S. Jayalakshmi from IIT Trichy, and Professor A. Srinivas Raju from Abdulani, and Engineer S. Satyaseelan from Teamage Precast in Tamil Nadu hold the principal honor of the event. It is for their contribution of the time, efforts, ScTACE 2021 has fixed up a head start. I am truly honored and obliged to all of you for bestowing attention to ScTACE and your commitment despite your busy schedules, and makes us feel fortunate to share a stage with you. Finally, on this occasion, I would like to take a moment to charm the success of ScTACE 2020 by obliging my appreciation and gratefulness for making success come our way. In continuation to that, to apprise the society of the importance of sustainable construction and relating to the value-added research in terms of the latest technologies, ScTACE 2021 encouraged interdisciplinary researchers and embraced contributions that span the engineering, allowing researchers and practitioners to exchange ideas on the latest developments in sustainable construction technologies and advances in civil engineering, and focused on providing collaborative opportunities. And finally, it's a time for us to be part of the international conference of ScTACE, and let us join hands in extending professionalism in the world of sustainable civil engineering. I believe this ScTACE 2021 adds value to your efforts, and I wish good luck to all the participants with their presentations, and I hope the audience will have a great time with ScTACE 2021. Thank you.
I would like to grab the opportunity on behalf of everyone to thank you for creating this opportunity to interact with all the experts in this ScTACE 2021 and being our pillars of support. Thank you so much, sir. Hereby, I would like to hand over this session to our other coordinators, Ms. Hema Ramastri and Ms. Saranya.
Thank you, Pujita and Sri Krishna. I, Saranya of 3rd Civil.
I, Hamaramashri of 3rd Civil, take this as a privilege to warmly welcome one of our chief guests, Dr. Samson Matthew Garu. Dr. Samson Matthew has completed his bachelor's from the University of Kerala in 1985, master's from the University of Calicut in 1988, and PhD from the University of Calicut in 1996. Currently, he is holding the prestigious position of Director of National Transportation Planning and Research Center. It is an institution under the Kerala State Council for Science, Technology and Environment. Prior to that, Dr. Samson joined IIT Tirupati in 1994 and worked as professor in the Department of Civil Engineering. He worked as Dean of Students Welfare and directed the Center of Excellence in Transportation Engineering at IIT Tirupati, which was authorized by Department of Higher Education, Ministry of Human Resource Development and Government of India, supporting the scheme Establishment of Center of Excellence in Frontier Areas of Science and Technology in 2013. Dr. Samson is well known for his progressive completion of 10 sponsored projects by the Ministry of Human Resource Development, Government of India, the National Rural Road Development Agency, the COI Board, etc. The estimate of his performed projects valued a sum of rupees 125 lakhs, and he also coordinated for few more projects that are worth a total grant of rupees 624 lakhs. He has also been into the consultancy work concerning transportation and is recognized for his
perfection in its accomplishment. Dr. Samson is a member of State Technical Agency of Prime Minister Gram Sadak Yojana program for Tamil Nadu and Pondicherry and has lifetime membership with Indian Roads Congress, Indian Society for Technical Education, Institute of Urban Transport, Institution of Engineers and Transport Group of India. Dr. Samson has delivered numerous expert lectures, keynotes and guest talks in renowned abroad and Indian institutions. He also organized various student and faculty beneficial programs. Dr. Samson is honored with Young Scientist Award for the year 1994. He has procured 36 papers in national and international journals, 29 plus papers in international and more than 100 papers in national conference. Dr. Samson areas of interest include transportation planning, traffic engineering, road safety, payment management and ITS. Now I request Dr. Samson Matthew Garu, Chief Guest of ScTACE 2021 to address the gathering.
Thank you. Thank you for the nice introduction. Good morning and good evening to all my good friend Professor Chen. Of course, listen, of seeing your face, we were going back at least some 10 years back to REC, NIT Trichy, and the association with you with the Professor late C. Natarajan Fellow. You recollect all those stories and all. Thank you, Professor Chen, Dr. Murthy, Engineer Radhakrishnan, my good friend KB Reknana Reddy, Engineer M.A. Joseph, the organizer Pada Srinivas, my student Pada Girish Kumar. Good morning to once again to all our good evening to the experts joined from abroad. I take this opportunity to thank the organizers for inviting me for this important conference. I'm very happy and I'm very happy to be with this associate with this conference. In fact, let's say now, Dr. Girish Kumar, he was inviting me almost for more than a year for different programs, and finally I agreed that listen I will join one program, and it happened that listen I could join this second international conference on sustainable construction technologies and advancement in civil engineering. My hearty congratulations to the organizers, especially my student Pada Girish Kumar and Sri Vishnu Engineering College for Women, the Department of Civil Engineering, the principal, vice principal, and the other organizers organizing this particular conference. I am very proud to note that my student is doing a wonderful work. When I was listening to the biodata or the introductory remark about Girish Kumar, I've seen that one. He's doing a wonderful work. After his PhD program at NIT Trichy, and in his short duration, he was involved in so many activities. Congratulations, Girish Kumar, for that.
Thank you very much, sir. It's all your effort. Thank you, sir.
No, we can only motivate and listen. That it is more important that you are taking it forward. I'm very happy to note that one. And not only that, listen, I've seen from the program schedule that so many experts and renowned professors from various institutes, IITs, NITs. Then I could see that one, Purdue University, University of Illinois, University of North Carolina, and all experts are joining. Maybe we should thank COVID for such an opportunity to interact, at least virtually. Otherwise, listen, it may not be possible that listen, we can meet together. Not practically, probably it may have difficulty. I was listening to Professor Chen. Of course, listen, we were working together and recollecting the memories at NIT Trichy and the activities he was involved, not only in China or in the US, across the world. He is involved, and NIT Trichy was lucky to listen to him and enjoy his lesson expertise. Thank you, Professor Chen, for that one. And I'm happy that Dr. Murthy, and a well-experienced traffic and transportation engineer, he was talking from his experience, what a civil engineer and what a transportation engineer do and all. I'm very happy that Girish Kumar, you have you got a very wonderful experts from across the world, and you are doing a good work. And I understand that the first conference was also a successful one, and that was the feedback I received from the other the participants. Now, coming to the theme of the conference, that is sustainable construction technologies and advancement in civil engineering, which is a highly relevant and important topic, especially for the economic and other development that is happening in India. Of course, all of you know that the Indian economy, as well as the Indian infrastructure, is growing at a very fast pace. And according to me, the sustainable development is the one which is more relevant for this era, especially for India. Maybe the definition sustainable development is the one which meets the needs of present without compromising the ability of future generation to meet their own needs. In a conventional probably lesson, I've been defining that sustainability for the last 2 decades or so. The sustainable development uses locally available expertise as well as the materials which are energy efficient and durable. In India, tremendous environmental problems are arising in construction industry, which are related to the civil engineering due to rapid urbanization and other development that are happening in India. Increase in demand of buildings, especially the residential buildings or other commercial and industrial buildings, that is happening in India. It requires a lot of energy, resources, raw materials, which are responsible for the rise in the carbon footprint. Everything now we have to connect that into the amount of carbon footprint we are creating. So I wanted to touch 2 major points today. One is the one which is connected to the buildings, or because that is very important in the sense that we are creating a new or a number of smart cities, supposed to be smart, and we are creating a lot of transportation infrastructure. So I just wanted to touch 2 points in today's discussion, and maybe the participants, those who are attending, I hope that they are all with a civil engineering background. As Dr. Murthy mentioned, that we should be proud that we are civil engineers, because we are creating the facility of the infrastructure for the society. So sustainability in construction is all about following suitable practices in terms of choosing materials, their sources, and construction methodologies, as well as design philosophy, so as to be able to improve performance, decrease the environmental burden of the project, minimize waste, and more than that, it should be ecologically friendly, taking into consideration environmental, socio-economic, and the cultural activities. So we should be very careful while you are taking a decision of a particular infrastructure. What is the design for that one? How the planning? What are the materials to be used? And what is the maintenance requirement? And which should not, let's say, give more damages to the environment, the socio-economic status of the socio-economic system that is existing, and the cultural values. So it is a big challenge for any civil engineers. The objective of sustainability is to achieve efficient use of resources like energy, water, and construction materials with minimum impact on the environment. However, because of the complexity of sustainability and the fragmentation of the construction industry, the level of implementation of sustainable construction practice is still low in India, like maybe other developed countries also. I wanted to press one concept, that is the life cycle cost analysis, which is an important concept to be considered for sustainability in infrastructure development. We have to consider the material production, construction planning, design, construction, operation and maintenance process for the calculation of the life cycle cost. You may think that certain construction technology may be very economical or the low cost in the beginning. Probably for the maintenance and operation, it may not be the economical one. So you have to consider the life cycle cost of the structure and judicially take a decision for the design, use of material, construction, and then the operation. The choice of materials for construction controls whole of life cycle impacts such as the emissions, gross, the quantity you are taking, properties of waste that are generated and returned to the environment, use of recycled waste and their own recyclability. Materials also strongly influence lifetime energies, user comfort, and durability. I just wanted to stress the point that the concept of reduce, reuse, and recycle. Now that should be the concept which any civil engineer should follow. That's as far as possible. We should reduce the consumption of these materials, natural materials. We should try to reuse, or probably, if not possible, we should recycle the material. Environmental sustainability includes the notion that sustainable construction is to protect the natural environment rather than pollute it by encouraging the use of renewable resources and reducing the use of water, energy, materials, and land at each stage of project. Technical sustainability requires high performance, durability, quality, and mixed use of building. Green technology in construction makes infrastructure more energy efficient and sustainable. So they have a lower carbon footprint and a reduced impact on the environment. Now we should use the digital or the electronics and the computer development that are taking place, which can use in the green building technology, which make use of the motion detectors, RFID scanners, access card readers, and other sensors to monitor the occupancy status of a building or the resident. Wherever an area of structure becomes unoccupied, green technology automatically shuts off the light and adjusts air conditioning system, cooling, heating, and ventilation options. So this is possible now with the advancement of the electronics and other computer systems. Building owners can realize as much as 30% savings in their energy expenses by eliminating unnecessary energy use in this manner. There can be another technology probably which you can use is that cool roofs, which are sustainable green design technologies, which aim at reflecting the heat which is coming from the hot sun and the sunlight away. It aids in keeping homes and buildings at the standard room temperature by lowering heat absorption and the thermal emittance. The design make use of reflective paints and the special tiles which absorb less heat and reflect away most of the solar radiation, so that the rooms below the exposed the concrete can be we can control that. So the minimize the dependence on air conditioning and in turn reduce energy use, the translate use, which translates into the decreased cumulative greenhouse emission from power plants. There are several water efficient technologies used, which are all part of sustainable construction technology. Essentially, the technologies encompass reuse and application of efficient water supply systems. Examples include the use of dual plumbing systems, one for the grey water, other for the drinking water. Grey water reuse is very important point. Rainwater harvesting you can do, and the water conservation fixtures. These methods ensure the water adequately managed, recycled, and used for non-portable purposes like washing cars, flushing toilets, and which can efficiently use for the greenery or the gardening or the plantations, etc. I can tell you that, the NIT Trichy is the best example where we recycle the water and use that one for the gardening and the tree plantations. And over a period of almost 5 to 6 years time, you can see that when the greenery of the NIT Trichy is totally changed. Maybe the Professor Chen and our Girish Kumar, they will be knowing that the fact. So this is possible, and maybe even instead of wasting your grey water, you collect that and recycle that and reuse that one for this purpose, so that the use of the good water, the drinking water, can be reduced. Now you should accept the fact that we are using the water, the good drinking water, for flushing the toilet when there are good number of people are not getting drinking water for their daily use. So we should think, the civil engineers should think this concept. Now coming to the construction of self-powered buildings, it's an art of sustainable construction technology. The buildings are designed such that they are able to generate sufficient power to support their own energy needs, and even direct surplus energy back into the power grid. Of course, most of you may be knowing that in the last 2-3 days, we are talking about the scarcity of coal in India for the power generation. But we are abundantly getting the solar power daily. We are getting good power from the wind. We have good locations where we can construct the dams and the hydroelectric powerhouses. We can do that. These are all something connected with the civil engineering. The buildings are designed such that they are able to generate sufficient power to their own energy. Example is the solar or the wind power technology can be used, and it is highly common in skyscrapers or the buildings, whereby solar power panels or the wind turbines are mounted at the rooftop, which generates the power requirement for the building. And the government is also encouraging that one, and in Kerala and all, we could see that one. Good number of solar power plants are coming on the rooftops, and after they are used, they are giving it back to the grid. So that it is a win-win situation for the government and to the public, as well as when there is a scarcity of power through the coal-based power. That time, we can use this as an alternate method, and we should encourage this one. And more than that, it will reduce the greenhouse emissions from non-renewable energy sources like fossil fuels or the coal, etc. Throughout the history of the earth, finally, when coming to my area, evolution and developments in transportation infrastructure have been closely involved in the generation of human beings. Transportation contributes to each and every country's financial, industrial, social, and cultural growth. Infrastructure for transport, such as the highways, railways, bridges, airports, docks, and canals, functions as a route for the mobility of people, goods, and services, and takes the shape of communities and cities. Construction, operation, and rehabilitation of these facilities have put tremendous pressure on local and state governments, including the loss of natural resources, and have contributed to the carbon footprint and emissions of greenhouse gases. We should see the amount of infrastructure, especially the transportation infrastructure development that is happening in India. Now, maybe some 10 years back, the daily outturn of the construction of road sector was only less than 15 kilometers per day. Now we have almost reached 40 kilometers per day, and of course the minister, central government minister Gadkari is looking for almost less than a 50-kilometer construction per day. That is the pace at which the infrastructure, road infrastructure is happening in India. Beyond that, on railway is expanding in a large scale, and the metros are coming up, new rail airports are coming, new ports and docks, the harbor systems are coming. You need materials for this construction. I just wanted to share that availability of the gravel is not there in Kerala. Quarries are banned, so the construction materials are led a lot of scarcity there in that, and some of the projects are stuck with this non-availability of material. So it is our responsibility to use the alternate materials, alternate design aspects, so that the use of the natural resources can be reduced, and or probably we should think that how to reuse that the existing material. I had a discussion with the government agencies yesterday and the supplier that many places, especially in the US and all in the developed countries, they are going for the full depth reclamation or the full depth recycling of the payments. That is possible, and inshallah, so that will it will reduce the amount of the requirement of the new material for the construction. Recently, we have taken up about 30-kilometer construction in Kerala, in which we have used 100% of the existing material for the overlay of a bituminous pavement, in which the use of the new material or the fresh the granular material was only around 30% of the total quantity. That way, if you implement that one extend that one to other highways network also, then probably you can save a lot. So measures of or matrices of both sustainability and resilience, and how they can be addressed together during the design, planning, and construction phases are key issues that need to be addressed today. And in that direction, the civil engineers, they have a major role to play for the development of infrastructure in any country, especially in India. This framework should provide a powerful decision-making tool for engineers, state and local agencies, and other stakeholders to choose appropriate design or construction alternatives while balancing both sustainability and resilience aspects. There is one difficulty in this direction, that which we have seen, that one, the confidence of the engineers or the confidence of the contractors we have to create. We should demonstrate that this is possible. Then only that confidence will come to the local contractors and the engineers. So that is a big challenge which we can do that one. In case of all modes, transportation infrastructure is always associated with the huge financial cost and time and labor consuming, at the same time undergoing degradation and failure due to the increasing traffic volume and the changing climate. These are all challenges we have to face. So the future development of the transportation infrastructure tends to be larger, longer, smarter, and eco-friendly, which brings new challenges to the transportation engineering. New research topics have been brought forward by the development and evolution of transportation engineering, where more and more attention is being paid to the integration of emerging technologies such as the big data, artificial intelligence, and the smart materials into the transportation infrastructure. It is coming in a large scale. It is coming. These technologies coming in the infrastructure development also, especially the transportation infrastructure. So I'm sure that the second international conference on sustainable construction technologies and advancement in civil engineering will be discussing these various sustainable and resilient construction technologies in today and the next 2 days. I wish a very fruitful time to the participants of the conference, and you are exposed to good number of experts and experienced professors and the practitioners, not only from India, from abroad also. Make use of that opportunity. Once again, I wanted to congratulate the organizers under the guidance by Professor Chen and Dr. Murthy. Thank you for guiding my student Girish Kumar, and I wish all the best to the organizers, and wish a fruitful time to the participants of the concrete. Thank you once again for inviting me to participate, share my experience with you all. Thank you. Thank you all, sir.
Thank you, sir. Thank you. Thank you very much, sir.
I thank from the bottom of our hearts for taking time from your busy schedule to be the part of ScTACE 2021 as a chief guest. Once again, thank you, sir. Now, I would like to take the opportunity to invite Engineer Radhakrishnan Garu, chief guest of ScTACE 2021. Engineer Radhakrishnan Garu, who graduated in engineering from Untitled University and is having more than 35 years of industrial experience. Please.
Hello.
Hello.
Sir, just a little technical issue, sir. Please hold on, sir. A minute.
A.R. Radhakrishnan, who graduated in engineering from Annamalai University and is having more than 35 years of industrial experience. His areas of specializations include manufacturing operations, manufacturing engineering, and project management. He was associated with leading corporate houses like Rane, TVS, etc. for more than 25 years and played key roles in manufacturing system design, new projects, and technology transfer from their overseas collaborators. After his superannuation, he took over as Secretary General of ICI in 2010, and since then he is looking after the administration of ICI from the headquarters. He toned up the administration of the institute for its effective functioning and governance. His passionate and tireless service to ICI has placed ICI as one of the most prominent professional bodies in India, evoking good response from all segments of the concrete industry. His close coordination with centers has been ICI as a strong and vibrant professional body, and the institute has grown up in leaps and bounds in terms of membership and number of regional centers. He initiates several new measures from the time to time to bring more recognition in the institute by submitting his proposals to the governing council and playing supportive role in translating them into action. He is the editor of ICI Journal and the bulletin in ICI Update. Now I request E.R. Radhakrishnan Garu, Chief Guest of ScTACE 2021, to address the gathering.
Thank you, Sri Sai. Good morning to all the learned professors, eminent invited guests, and budding civil engineers, the nation builders of tomorrow. At the outset, I thank you all for inviting me to be in the midst of you all in the inaugural function of the International Conference on Sustainable Construction Practices and Advancement in Civil Engineering. I am really delighted to know that eminent experts from different disciplines are going to enlighten the participants. As civil engineers, you are the real nation builders. Whatever you are going to do in your profession is for the betterment of the society. You are going to build shelters, infrastructure facilities like bridges and roads, airports and seaports, water reservoirs and canals, water treatment and supply, malls and multiplexes. Everything is for the betterment of the society. That way, you all can be proud of becoming civil engineers. Every development is to be a sustainable development. Then only it could be considered as development in true sense. As professionals, we are expected to care for the society and for the future generation. That way, the topic chosen for this conference is of paramount importance. ICA is a professional body dedicated to the cause of disseminating knowledge on good concrete construction practices. Concrete is the most essential construction material for the civil engineer, and hence the focus on concrete. The events like seminars, workshops, conferences, etc., conducted by ICA provide the platform for people from all segments to share their knowledge and to learn from others' experience. The technology is changing fast, and so also the civil engineering. There is a revolutionary advancement in civil engineering in terms of materials and processes. Sustainability and durability are the watchwords today. The curriculum cannot capture all the developments and advancements that are taking place then and there as they happen, and hence there is always a gap between the theory learned from classrooms and what is being practiced in the field. This gap is a hassle for fresh engineers to face the challenges in the field, either to make an entry or to shine thereafter. ICA aims at helping the students to bridge this gap by exposing them to the outside world through their participation in the ICA activities. Students get an opportunity to listen, to interact, or to listen to the practicing experts to get updated on the latest technology and practices. You can interact with the researchers to get to know what kind of research activities are going on in the laboratories. You will get to know what are the opportunities ahead of you so that you can prepare for yourself to make a head start in your career. Number of technical committees are formed by ICA from time to time, pulling up experts from the industry in different disciplines to bring out valuable technical documents for the benefit of practicing engineers and others. Many of these technical documents are uploaded in our website. If you visit our website, it is a treasure for you to find out what is of your interest. An employer expects three things from a fresh engineer. First of all, he has to possess sound theoretical knowledge, what he acquires from the classroom lectures. Then he is expected to be good in soft skills, known as managerial skills like leadership qualities, analytical ability, decision making, team building, communication, presentation skills, etc. Thirdly, they expect the candidate to be updated on the latest practices in the field. With all these, they are confident that a fresher can start performing from day one. In the next 3 days, you are going to listen to such experts who are going to share their knowledge with you. It is an opportunity to you all to listen to such experts. I thank the management of Sri Vishnu College of Engineering for Women for their efforts to shape you all well to become successful engineers and responsible citizens. I would like to place on record my sincere appreciation to Dr. Pala Girish Kumar, who has put in a lot of efforts to organize this program. It is truly international program, and I am able to see the profile of the speakers. It is really very impressive. I am able to imagine what kind of efforts you might have put in to organize this international conference. I wish you all the best, and thanks for your patient listening. Over to the organizers.
Thank you very much.
Thank you, sir. I would like to take this opportunity to thank you on behalf of everyone who were captivated by your talk, and thank you, sir, for being a part of ScTACE 2021. Now I request Faculty Coordinator P. Lavanya Garu, Assistant Professor in the Department of Civil Engineering, Sri Vishnu Engineering College for Women, to present vote of thanks.
Thank you, sir. Respected Professor Chen sir, Dr. Moti sir, Dr. Matthew sir, and Engineer Radhakrishnan garu and Dr. Pala Girish Kumar sir. Thank you, sir. We are deeply grateful to you for presiding over and for your thoughtful address. May I, as one of the family of Civil Engineering Department, take the liberty of adding a couple of remarks to this welcome address. Predominantly, I would like to express our appreciation, enthusiasm, and high degree of commitment which you have shown prior to this meeting. I am chuffed to share that about 250 entrants participating from chromatic institutions, organizations across the world, making this conference a truly international conference in spirit. I would like to thank and acknowledge all the delegates and the support team who have extended to make this conference viable. I have to extend further thanks to the ones who greatly helped in organizing the conference. Firstly, our predecessors for their extreme support, and secondly, we are appreciative to Dr. Pala Girish Kumar, the person who have made this conference possible and can certainly inspire us all during the conference in these 3 days. I wish everyone in the name of ScTACE 2021 a successful and enlightening conference. It is a pleasure to hand over to you, Ms. Hema. Thank you, sir. Thank you very much.
Thank you.
Thank you, ma'am. Thank you, ma'am. Let us.
Hema, a minute. I just wanted to convey again one more time my gratitude to all my gurus Sir Shen sir, I'm extremely happy for your presence today, late night. It is really late night to you. Maybe it's 1:30 a.m. So you are taking efforts to attend, sir. Similarly, Dr. Moti sir, thank you very much, sir. Always you are helping me in coordinating in different things and motivating us in lot of interactions.
You're
And
welcome.
Matthew sir, my one of the favorite professor at NIT Trichy. Always I'm very afraid of you, but still I learn a lot of things from you. Thank you very much, sir. Whenever I see you, I get that kind of energy and boost up from you, because even I could remember the very recent meet we had in GAM 2020 in Chennai. Thankful to you, and I wish always I meet in person, if at all, if is there any opportunity. Thank you, sir. And Radhakrishnan sir, we are associating since 2019 awards. So that day I met you on that ceremony, and it was a grateful to you always. Back up and get some suggestions from you. Thank you, sir. We are expecting this coordination and help and support, encouragement in future also. Thank you very much, sir, for all your
Thank
presence. Thank you, sir.
Thank you. You're welcome.
Good luck, Girish.
Thank you, sir. Thank you.
All the best.
Yeah.
All success.
Bye, sir. Yeah. Please proceed with Hema. Yeah.
So we have leave. Thank you. All the best.
Thank you, sir. Thank you very much, sir. Thank you.
Let us proceed forward with the keynotes followed by the panel discussions. Firstly, I would like to introduce our renowned speaker, Professor Aldo Garu. Professor Aldo completed his BTech from Mahatma Gandhi University, Kerala in 1988, MTech and PhD in Civil Engineering from IIT Bombay in 1992 and 1995. He is an Institute Chair Professor of IIT Bombay with more than 30 years of experience in the area of water resources and environmental engineering, a scientist, professor, and consultant. He is a recipient of many prestigious awards, including Eminent Water Resource Scientist, constituted by Indian Water Resource Society in 2018. He is also a research proposal reviewer for many research organizations and delivered several invited keynote lectures at various national and international organizations and conferences. Professor Aldo serves as an editor, associate editor, and editorial board member of several Indian and international journals, and has worked as reviewer for more than 50 national and international journals in the recent past. He has published more than 450 research papers in various international journals and conferences. He has developed and offered 25 courses and number of short-term courses for college teachers and working professionals. He has also developed 2 popular video courses on fluid mechanics and watershed management. Dr. Aldo has co-authored 2 popular textbooks and contributed 12 book chapters in various edited books. His area of interest involves fluid mechanics, coastal hydrodynamics, climate change impact on water resources, CFD, groundwater flow, and contaminant transport. Thank you, sir, for your presence in ScTACE 2021. I take the honor to hand over the session to you, sir.
Okay,
Welcome,
thank
sir.
you very much. Thank
Good
you.
morning.
Morning, Dr. Girish. Okay, so first let me share my PPT. Okay, this PPT is visible now?
Sir, it's sharing, sir. It's about to share. Yes, sir. We are able to see, sir.
Okay. So can I go ahead?
Sir, can you please make it full screen?
Okay.
It's done, sir. Yes, sir.
Yeah.
Yes, sir. Please proceed.
Okay. Okay, so thank you very much for the introduction. I am very happy to get associated for the second International Conference on Sustainable Construction Technologies and Advancement in Civil Engineering. I think Dr. Girish already put one conference in last year, and I was also a keynote speaker for that. This is second time. So I am very happy to get associated and also give a lecture in this as a keynote for this international conference. So I was here, though I was not fully participating in the inaugural function. I heard some of the talks by some eminent people. So I am very happy to see that this time you could get many international speakers, and then it is really international, and then you have got a nice inauguration in the morning, and we look forward good opportunities in future also. I think you are calling this second international, maybe every year you are planning, I do not know. So that will be very nice, and then very nice to get associated with you. So the topic has already, you can see that sustainable construction technologies and advancement in civil engineering. So you see that last few decades, so much of we are talking about sustainable development, since always whatever is happening, whatever the way the developments are happening, it should be sustainable. So it is not only sustainable means it is not only for this generation. So the whatever we are developing, what we are doing should be useful, and then also should be appropriate with appropriate windows. It should be applicable to future generation also. So that way this topic is very relevant, sustainable construction technology, since we need to have a lot of changes. You see that now countries like India is concerned, huge infrastructure projects work is going on, starting from very big highways to then bullet trains, and very, very big projects are going on. So that way, whatever we introduce, whatever we do should be sustainable, and then also we need to talk in terms of what can happen in future. So that way, my topic is say not directly on construction technology, but whatever you construct, that can get everything go if you are not taking care about the floods. So that is what is the most important aspect. So though, like of course, India, we are having flooding problems every year in many places, but you would have read in newspapers last month what has happened in Europe, like highly advanced countries like Germany, France, UK, etc. Many countries were very much affected due to the floods. And then whatever is built, say for example, if we are making anything what is possible in years, I mean 1 or 2 decades of work can vanish in 1 or 2 days. So that is the impact of floods. So whatever we are doing, if it is not done properly, if the construction technologies are not in proper, whatever we are doing is not proper, it is not sustainable, then whatever we are building for centuries or even decades, that can vanish in a few days of flooding, and that is what is the history says. So that way, this topic of what I am going to talk is about the urban development by considering flood management in changing climate still scenarios. So after the Paris Agreement in 2018, now the 6th annual assessment report is already available. Then you would have read in newspapers. So what are the possibilities that can happen throughout the world, and especially in a country like India. So I will be also covering some aspects of climate change, and then what we can do as a scientist, as an engineer, especially civil engineering is concerned, what way we need to take care, how the sustainable development, especially sustainable urban development is concerned. The topic is sustainable urban development by considering flood management in changing climate scenario. So I'll be first to talk about what is urban floods, what are its issues, and then we will have a brief introduction on climate change. So next half an hour I'll be talking on various aspects, and then as an engineer we need to model various scenarios, and then also we need to look into various aspects as far as flooding issues concerned, especially when we talk about smart cities or sustainable development. And then we are looking whether we can have a possibility of flood warning system and how we can manage if the flood happens. So I'll be also discussing some of the flood model we developed at IIT Bombay as part of some projects, and then also a few case studies will be presented. I hope I am audible and everything is okay, Dr. Girish?
Sir, everything is done fine, sir. Very fine.
Okay. Okay, so now coming to, since we are talking about the construction technologies, especially in terms of urbanization. So when we talk about urbanization, we can see that there is so many issues can be there. So that you can see that in the urbanization issues here, I have already listed some of the important issues like the soil impermeabilization and the decrease of the concentration time. So you see that whenever the urbanization takes place, you see that a lot of development takes place, and then say how the hydrology will be affected. So of course urbanization means so many aspects we need to look into, but I am talking in terms of hydrology. Hydrology is concerned, so much of impacts will be there, like soil impermeabilization, decrease of concentration time, increase of runoff flow rates, then reduction of river beds, and increase of flooding frequency, and lots of potential water uses. So there are different aspects water is concerned. One is you need to supply sufficient water to the city, especially when we are talking of the smart cities or any kind of urbanization. That is one aspect. Second aspect is then these kinds of hazards like flood hazards. So both aspects we need to put it in appropriate form, appropriate management. Then only we can say we are going for sustainable development, and we are following sustainable construct technologies. So that way, when you talk about these kind of issues, then we need to see that the increased surface runoff is you can see that one important aspects here, and then the increase in magnitude of peak runoff. So that is what is, whenever you are having more urbanization means more the peak runoff will be increasing, and then we will be having decreased lag time between rainfall and runoff response time. Then increase the rate of hydrograph and recession. So these are all some of the issues. I am talking only in terms of hydrology, but there are so many issues. Now, if you look into what is happening in most of the countries, especially in a country like India, most of the developments are taking place either on the banks of the rivers or the coastal areas, especially we have got western coast, eastern coast. So coastal areas or the seaside or the river side, most of the developments are taking place. Every cities if you take. So that way, and now whenever the city, the beginning, there is no planning most of the cities, and then later when we are trying to impose something, but already construction, already many activities are already taken place. The cities are developed in the river banks or even floodplains of the river. So that is a major challenge. So that is why this land use planning is very, very important in any kind of smart urban development or urban development is concerned. So that way, you see that the various issues related to whenever we are talking about the hydrology, when we are talking about floods, what is the impact of the urbanization? You can see that if a normal watershed, normal area, normal catchment, for a given rainfall condition, we call it as hydrograph. So hydrograph is like this, a flat hydrograph. But if it is urbanization, means this can become very peak. The peak can increase and time of concentration can decrease. So that is a major challenge as far as the hydrology cycle is concerned with respect to urbanization or the whatever we are doing, say as far as cities are concerned. So that way, we need to see that how we can deal with this reduced time. I mean now, and then also how we can deal these kinds of peak. So you see that now, as I mentioned, the climate change, whatever all the projection says, now the rainfall may increase many locations, and whatever the rainfall takes place, it will be taking place in few events. So few events means very high intense rainfall can take place, and then all these flooding events like what has happened last few weeks in Europe and other countries. Similarly in India also, Bihar and other places. So then you see that high impact will be there, and then all the issues will be becoming flooding issues, and its hazards will take place. So that way, you see that if you look into the flood hazards, the sustainable development and flood hazards are concerned. Floods are the most threatening natural disasters. So whenever we plan anything, whenever we do the urban development or smart cities, we need to see that these kinds of issues, urban flood problems. So if you consider India, this is a series of floods. So many years we can see last year, say now in Assam, flood in Assam, Bihar, now Kerala 2018, Chennai 2015, like that. Every year major floods are taking place in a country like India. So since I am talking from Mumbai, Mumbai is also every year either major floods or minor floods. Flood is there every year. So that way, so we need to see this what is happening, and we need to also study it properly, and then also we need to go for planning as far as the urbanization is concerned or urban development is concerned. So that way, flooding is a major threat to sustainable development of cities. We need to deal accordingly. So when we talk about the flood impacts, so in terms of sustainable development, so you can see that there is huge impacts will be there. It can be in terms of economic, it can be in terms of environmental damage, it can be in terms of health epidemics, disabilities, etc. So if you take each flood series, say for example, I will start since I was also a victim of flood in Mumbai 2005 flood. So there almost 500 people died, and then say 70 crores of rupees even lost in one industrial at MIDC itself. And then Chennai flood, if you take it 2015, you can see that about 7 to 10 US dollars, billion US dollars were lost, and more than 400 people died. So Kerala flood, which was 2 years back, death more than 300, and estimated loss is about 30,000 crores rupees. So that way, this is a major issue when we are talking about smart development or smart cities or construction technology, sustainable development, all those things. So as civil engineers, we need to deal with this and how to plan by considering all those things. So here, when you talk about what are the factors responsible for this, it is not one factor. It is not only rain. There is so whatever our activities like human activities, the development what is taking place without considering the sustainability. So that is one major factor. And then of course natural events of rainfall, and then man-made event like climate change. All these are factors. The solution for sustainable development. So we need to see how we have to manage. We need to design it properly, and then we need to maintain and aware. So that way, in terms of civil engineering, we need to talk about engineering, modeling, scenarios, then what are the various options available, and then how to implement all these options for appropriate management. So that is what we need to see. So now, when we talk about this is everywhere increasing extremes, we can see like as I already mentioned, say India is concerned. So every year, so many times we can see these flooding events in India, either western coast or eastern coast, or say north, like I have already listed a number of flood events already listed. And then we are going to the cyclones. So cyclone is also a major impact, major factor, which is so cyclone map. If you take all the years, we are having the eastern coast is affected by cyclone, and then western coast, say the last year, this year also there was some cyclone activity. So the cyclone also part of the major cause for the floods. So then coming to climate change. So we are all talking about climate change. So climate change risk is concerned, it is say related to risk from extreme events such as heat waves, then extreme precipitation, cyclones, and coastal flooding. So you see that as per IPCC reports, you see they have classified climate change risk index. So they have put, and India comes, say Philippines the most affected, then Cambodia, and then third one is India, especially India with so much of coastal region. We have got say climate change risk is very high. So that way we need to deal these kinds of climate change influences. So climate change is concerned influence of climate change and human intervention, regional hydrology. So climate change, changes in global climate will have a significant effect on regional or local hydrology. Then alteration hydrology caused by climate are complex. The warming of climate have potential to intensify hydrology cycle. So these are the climate change. So especially we are talking about increasing temperature due to various anthropogenic activities. So that way the climate change is now we can feel, we can say last 30 years data if you assess, it is definitely there everywhere, that impact is there. And then, as I mentioned, human interventions, like I was talking, it is not only climate change, whatever way we are developing, our development scenarios, like sustainable development when you are talking, so sustainable construction technologies when you are talking, how we are developing the human intervention, change in land use, land cover, dams, diversion, all those things are very, very important. So we need to, whenever we talk about these kinds of assessments, we need to see the human interventions and climate change, and then we can separately assess all these issues, and then also combined impact also can be assessed. And Dr. Girish, I am audible, everything is fine?
Sir, everything is fine, going well, sir. Please proceed, sir.
Okay, so now when you talk about climate change, so you see that as I mentioned, the climate change is especially due to the increase in greenhouse gas, and then also the temperature rise. There is it can be due to industrialization, it can be due to greenhouse gas emission, LULC change, etc. So the consequence of climate change is too many. So we would have already say, as I already mentioned, the flood is the topic which I am now discussing. Then many locations there can be droughts, and also can be also forest fires. So these are the three major impacts as far as the hydrological impacts or related impacts with respect to climate change, which is every time we are visualizing, especially in a country like your United States, California state, you would have already read in newspapers, they are having huge forest fires, which is also caused due to the, so nowadays we are identifying it is due to the climate change and related issues. And then last year we have heard from Australia, and then other than floods and drought is also many locations. So even whenever we are having floods, after say events of floods, then we are having a very lean period of rainfall, and then it can go to the droughts. So that is the major issues. So now, as per the latest assessment, AR assessment report number 6, climate scenarios as per IPCC, they have now, instead of this whatever is the earlier, like RCPs, earlier regional concentration path was the whatever the terminology in assessment report 5 they were using, but now it is they are changed to shared socio-economic pathways. So this is important. So what is now currently is shared socio-economic pathways, and that like is the latest is 2021. So according to IPCC, they are classified into SSP 1, 2.6. So if we can cut down our emissions and then we can reduce that rise in temperature, then we can go to 2.6. But with current rate, it can be go to will be 4.5 SSP. That is shared socio-economic pathways. And then if if we are increasing our emissions by rapid urbanizations and then all kinds of industrial activities, then we may go to even 7 or 8.5 with a very high greenhouse gas emission scenario with additional efforts to contain emissions. So these are some of the main issues. So then what are the related issues you can see here? So the temperature is rising due to future emissions, additional warming, all those things. We can see the temperature rise can happen with various scenario. If you can cut down, it can go to 2.6. It will be coming down. But now even a 2 degrees centigrade rise by end of the century, that it is very detrimental. It will be very, very difficult problems can come. So here this is as per IPCC future emissions case, future additional warming with the total warming. So here you see that with respect to carbon dioxide increase, how the variation can take place, and other CO2, then nitric oxide, and then other kinds of sulfur dioxide, all those emissions, how it can influence with respect to various SSPs, which I already mentioned, shared socio-economic pathways. So here, if it is SSP 1.9, 2.6, we are safe. But even if we can keep it till 4.5, that is okay, but we cannot go to 7 or 8.5, which is with a high increase in greenhouse gas emissions. And then it will be the temperature variation is also listed here. What can happen? It can even, if it is going to 8.5, means even the temperature can rise to even about 4 degrees centigrade by end of the century. But if we can cut down to 1.4, even 2 or below 2, that is the best way we can control many of these issues. So that way, when we talk about climate change and its impact, so there is huge impact on hydrology. And then whenever the temperature is rising, you see that the sea level also can rise. So this is already observed many locations, like even 1.5 mm rise last few decades. And if it is like 4.5, then it is reasonably okay. But if it is going to 8.5, the rise can be much more by end of the century with respect to 1900. So up to 2000, it was very small. Then you can see it is slightly going up. So that kind of things we cannot permit. And now with respect to precipitation, you can see this shows the precipitation increase. So the green or the bluish kind of this shows many areas the total rainfall may increase, and some areas it may decrease. So our country, India, you can see that many areas it is projected that by end of the century there can be more rainfall. And then also the soil, the evapotranspiration also can increase due to the temperature rise. So that is also quite detrimental as far as the climate change and its impact is concerned. So by studies, by some of the studies done reasonably by various teams, it shows that after bias correction of all the GCMs, we are having the very sophisticated mechanic tools like general circulation model or global circulation models, which we can download and then also do appropriate bias correction, and then show that this latest study shows that there is a possibility, say by end of the century, the rainfall is there is a possibility of slight increase in many areas with respect to this shows precipitation and there is slight increase in many locations, and then maximum temperature, all the locations it is increasing, and this shows the minimum temperature is also increasing. So that is quite detrimental as far as any kind of urbanization, any kind of development, especially coastal regions, there will be a huge impact. So that way, you see that some of the observation, if it is not going to 4.5 SSP 4.5 or 2.6 like that, if it is 5 and above, we are having approximately 20 to 40% increase in annual mean precipitation, and then a mean annual temperature may rise by 3 degrees to 4 degrees centigrade by end of the century, as I already mentioned, and a mean annual minimum temperature also may rise. So this first figure shows with respect to the precipitation. Most of the places precipitation is increasing. So this is we want to have this 4.5 scenario, that is the best scenario as I mentioned, and this is the worst scenario of 8.5. So at least the 4.5, even the same pace we continue, many locations they will be having increasing rainfall, and then also temperature, most of the places it is a drastic increase. You can see here up to 2 degrees centigrade, and if it is the 8.5 scenario, the worst scenario comes to with more than 3 degrees centigrade. And similarly, minimum temperature also will be rising. So some of the relevant the references are also given here. So that way, when we look into climate change and its impact as far as urbanization or flooding is concerned, we need to study in details. So increase in river flow rate, then change in water use pattern, all those things will be affected. Even power generation will be affected. We will be having more frequent floods, more serious debris flows like landslide and its impact. And afterwards, there can be also high risk of droughts. So these are some of the climate change and its impact, that is factors affecting with respect to urban flooding. So now coming back to solutions, as a civil engineer, we would like to discuss what are the possible solutions, how we can study these and how we can go for adaptation measures. So for that, we need to have a lot of data. We need to go for engineering simulations. So for that, the data can be like hydrometeorological data we need to collect. Then immediate water management after forecast. So like what kind of scenarios we can generate, and then what is the best adaptation measures. Then, of course, you see that in most of these flooding scenarios, cities are very much affected. So that is local areas. So then we need to develop appropriate urban flood models, and then we can, based upon that, we can develop flood hazard maps. And flood hazard maps, whenever vulnerable areas are superposed with flood hazard maps, we can get a map called risk map. So this risk map generation for all cities are very, very important. So that is actually some developments are taking place, but all civil engineers, all engineers can come together. We can develop such a risk map, and then we can restrict the use of the land use planning can be done appropriately, so that no further development takes place in the floodplains of the rivers, or appropriate form of development has to go. So then using all those things, we can go for impact, adaptation, and vulnerability assessment. So some of the key challenges include we need to collect a lot of data, then like rainfall prediction, drainage, high resolution detail elevation model, all those things are needed. Then we need to understand what are the interaction taking place between the coastal region like tides. Then if you are some of the reservoirs releases water, then what will happen, then what are the impacts of urbanization, then what is the initial condition, like whether we can have a real-time flood monitoring, like sensor installation, maintenance of sensors, etc. So these are some of the challenges. So that way, when you talk about flood model, so we need to, since the issue is that it is very much localized, like in a small areas, and then we need to know minute-wise, the time is very important. So flood happens in a few hours time, and then everything is gone, and then again it is receding. So that way we need to understand minute-wise variation, how it is happening, and then also spatial variation. So that way we need to develop distributed models, physically distributed model in terms of the governing questions concerned from mass, momentum, etc. And then we need to with forecasted rainfall, we need to run the model, and then identify which area may be affected. Then we need to give appropriate warning to the people, and then we need to take adaptation measures. Adaptation measures generally possible. We can even we can predict the possible rain for 25 years, 50 years return period, 100 years return period, and then we can go for adaptation measures, possible measures. So this shows, this photos show some of the what was happening in Kerala 2018 floods, say for example near Ernakulam city, Cochin city, or what kind of scenarios has happened. So whatever you develop in terms of all your sophisticated technologies, if this happens, what is shown in this figure, then everything is will be vanished in few hours time. So that is where we need to deal these kind of issues. So now as an engineer, so as I mentioned, as part of some projects, we have developed some model at IIT Bombay. So how you develop a model? So being, I hope all of your civil engineers who are hearing me, so you can think about how to develop a model or how to use a existing software to develop a model. So we need to know the rainfall. We need to know the overland flow, like whatever is happening with respect to overland. Then, of course, next lecture is by Professor Nagesh Kumar. Will be talking much about GIS and remote sensing. How? So here we need to integrate all these tools together, and then we need to go for how the floods are affecting the rivers or channel, and if it is near to the sea, then tides how will be affected, and then we will have a flood model, and then that when you run for the given rainfall condition, we are having the flood inundation maps, and then we can depict how it is happening. So that is what I am going to demonstrate in next few slides. Dr. Girish, everything is fine? You can see everything?
Yes, sir. Yes, sir. Model component slide. Everything is fine, sir.
Yeah. Okay, so then, so here if you are developing a model, we need to conceptualize. So this is called overland flow. This is a river or channel, and then how the flood will be interacting when the rain happens. It is going up or down, and then that kind of simulation. So generally, a three-dimensional model will be very, very difficult process. We can go for a 2D model combined with 1D river model. So that is what generally we do in these kinds of models. And then, so here now, we are talking about GIS and remote sensing. As I mentioned, very sophisticated tools are now available. So we can, since we need a lot of data, so we need to have remote sensing tools, remote sensing data, and then GIS tools. So requirement of flood modeling tools readily usable. And then, so whenever we develop such model, we need to see that any ground level engineer has to run it. And then he should understand what is happening, where is any possibility of flooding, all those things he needs to study. So their requirement of modeling tools include readily usable for field engineers, require no high-level expertise, easily accessible. Then challenge and computer modeling for urban simulation include most existing public flood packages are 1D's nature, but you need to say, for example, tides will be there, rainfall will be there. So many complexities we need to put together, and then it has to come on a GIS platform so that we can visualize which area will be affected, how the flooding will be spreading. So here we developed a model using the so flowchart which I have shown in the last slide, and then we put in a WebGram server so that we can easily visualize. So here this is what we are done here at IIT Bombay. So here an organization intranet, and then various users are there. So we put this model in a particular in a WebGIS server, and then that can be accessed by anybody. So that is the way we developed this model. So here some of the details of this model, it is published in Journal of Computers and Geoscience in 2014, and the model include these components. So here we have got a flood model is developed, overland, channel, and a floodplain model, and then it is connected to WebGIS server, and then through which entire operation will be taken place, and each user can access from user 1, user 2, like that. So one advantage of this model is that it is put it in a Google platform. So you can see Google Map directly, you can see. So we have developed this model for New Bombay or Navi Mumbai region. So here this area you can put it. So here you can see these are the various catchment we tested this model. And then the model input is rainfall and the tidal variation. So if it is a coastal area, tidal is also important component. So once you develop a model for a particular region, then the rainfall is the main component. And then once you feed the rainfall, then directly we can see the hydrograph, and then on the river cross section how the flood will be changing, and we can also get an animation how the area will be flooded. So that I will demonstrate in the next coming few slides. So here also as a part of some projects, we have done a flood study for Chandrapur city. So Chandrapur city is a city in Maharashtra where the entire city, most of the city, almost 70% of the city is situated on the floodplain of the river Erai. And then you can see that here, this is the river, there is an Erai dam, and then this is the river flowing, and this is the area wherever the city is there. Most of the part of the city is in the floodplain. So every year, whenever the river level rises, then flooding is there. So one important aspect which I mentioned is land use, land planning. So here you can see the city itself is developed in the floodplain. So you need to see how we can live with the floods. So we cannot avoid the flood whatever every year, but how to live with the floods. So that is what here we used a package HEC, GHMS and HEC RAS model, and then we developed a intensity IDF curve, intensity duration frequency curve for 25 years to 50 years, 100 years, like that. And then we identified which area will be flooded and where we had to put a stop on further development in the city, I mean urbanization, and then what kind of measures to be taken. So this is the publicly available model, HEC HMS model, and this is the output by putting various boundary conditions and running the model. You can see that for 25 years return period, 100 years return period. The most affected area in some areas, even it can go to 15 years from the center of the, of course, actual flooding will be hardly 5-6 meters above the bank, but this is from the center line. We can see that how this is the Chandrapur city region, how the area will be affected. You see that most of the city is in this area. So we can have this kinds of floodplain map by using even available open available sources maps. We can develop very sophisticated tools and then say that yes, this is to be done, and all cities should have these kinds of plans so that further urban development is put in appropriate form and there is no further encroachment to the floodplain of the rivers. So you can see here this is called in Maharashtra government, we call it as blue line for 25 years return period, and 100 years return period we say the red lines. So this red line zoning, so accordingly the development should be stopped in this region. And then we are discussing about a model developed at IIT Bombay. So here I will show how it is giving their details. So flood model, this is a case study in New Bombay region. So the details are shown here. We have developed the model say by taking the detailed based model remote sensing tools were used, and this is the 2005 to July 26 flooding, and then we plotted what is happening. So here tide is also this is very highly urbanized. There about 70% is urbanized, and then here the river is going and that is joining the creek, and with respect to tide and the rainfall, how the situation is changing. Minute wise we are captured here. I will show some of the simulation, like there is some detention bond also there, and this is the coastal area, how the flooding can happen. So this is the first 2 hours, then 6th hour, every hour I can plot. I am showing only 12 hours when tidal cycle is over. Then again it is receding back after 20 hours, how the flood is receding back. So that way this kinds of flood hazard map can be generated, and then using this flood hazard map, when you club with the flood vulnerability maps, then we get the flood risk map. So flood hazard map for each flood causing the river basins, flood hazard map based on historical data we can prepare, and flood vulnerability map also depends upon coping of ability of affected resistance and resilience. So flood risk is equal to vulnerability multiplied by hazard. So here you can see various return periods, how we are developing these, and then a money information system we are putting. And then this is the flood hazard map, either using the model which I mentioned for IIT Bombay, or you can use HEC HMS kinds of models. So this is used for another area in Mumbai city, like Mithi River, where airport and IIT Bombay is situated. So you see that this shows how whether highly vulnerable, I mean flood hazard map very high, low, like that it is classified by using the HEC HMS return, using 100-year return period for Mithi River basin. And then we superimpose with various vulnerabilities like social vulnerability, infrastructure vulnerability, impact of land use, etc. And final output is a flood risk map as shown here. So you can see that most areas are this area is very high, and then this is moderately high, and very low. So like that we can classify. So one advantage is that if the builder is going to build a building, then the people knows whether the building is in a high risk area, then they should not buy, so that no further development will take place in that area. So that kind of this kinds of risk map is very, very important for most of the urban areas. And then also now, as I mentioned, we deal with the floods. So there we need to have disaster management cycle, and disaster management center should be there. So after 2005 flooding, Mumbai city has done this, and now a very efficient disaster management cell is there, where all the data are connected and they give appropriate warning. But a live flood model is still not implemented for Mumbai. So finally, to conclude, so you see that in any urban development, so you see that this is a situation in Cochin airport in 2018 August flooding. So the urban flooding is very, very detrimental and most impactful, highly impactful or disastrous events with respect to our sustainable development or sustainable construction or sustainable urban development and smart cities are concerned. So we need to integrate scientific and technological and administrative agencies for effective disaster management, and then guiding principle in cities. Smart city development is we need to see these kinds of vulnerabilities and then make appropriate mitigation measures. So urban flooding, especially in coastal areas, are a major problem. Coastal urban flood simulation, major challenge. I have already mentioned some of the major challenges, including various aspects, including the climate change. So integrated physically based modeling approach needed to capture spatial and temporal variation. And then also, as I mentioned, we have developed an integrated tool like a WebGram server and WebGIS model, so that can directly say what can happen, what in the future, and then we can club this model with the climate change scenarios like 8.5, SSP 8.5, or whatever the scenario you want, and that can show what can happen in future also. So forward path for smart cities, generation of flood hazard maps and identification of vulnerable areas serve as platform for near real-time simulation, development of flood vulnerability and risk map. So finally, the last slide, changing climate and its impact, that is very obvious. So we need to get prepared. We need to go for appropriate research and studies, all areas, impacts posed due to climate change, impact due to land use, land cover change, combined impact to be assessed. And then we need to go for adaptation measures, and then that way urban flood is a major problem, and that way we need to take into account in any of the sustainable development programs. So some of the goals identified for sustainable urban development include comprehensive water database in public domain, reliable assessment of impact of climate change, promotion citizen and state action for climate change impact, and focused attention for overexploited areas, so dealing with extremes like flooding and droughts. So that way this conference is a very important topic, like sustainable construction technologies and advancement in civil engineering. I hope so I have seen the list of speakers, so many topics are covered. I hope all of you will be able to enjoy, and that I look forward to see the impacts later from Dr. Girish. So I'm very happy to give this lecture. If you have got any question, one or two question, or as well, if very specific questions are, I'll be very happy to answer, maybe coming 2-3 minutes. So thank you very much.
Thank you, sir. Thank you very much, sir.
So if you have got any questions, either you can email me, or if the organizers have time, I'll be happy to answer a few questions if anybody has any questions.
We will move forward to the next session. Time is lagging, sir. I will be forwarding them whatever questions I have. Will be do it, sir. Thank you very much, sir, for your acceptance and the nth time we are doing it. Thank you very much for your kind acceptance for everything. Yeah.
Okay. Thank you very much. Thank you.
Dr. Professor Nagesh Kumar sir is there.
Good morning.
Okay, thank you.
How are you?
Fine.
Hi. Good to see you. Yeah. Thank you.
Yeah. Good morning, sir.
Morning. Good morning, Girish.
Yeah. Please proceed, please. Next proceedings.
Thank you, sir, for the knowledge which you have shared with us. This will help us immensely in our further development. Once again, thank you, sir. And now, I would like to introduce the eminent speaker of our next keynote, Professor D. Nagesh Kumar Garu, on remote sensing, GIS, and DEM for flood indentation modeling. Professor Nagesh Kumar Garu obtained his bachelor's degree in civil engineering from V.R. Siddhartha Engineering College in 1984, master's in hydrology and water resources engineering from Center for Water Resources, Anna University in 1987, and completed doctoral in water resources systems from Indian Institute of Science, Bangalore in 1992. He is currently working in the Department of Civil Engineering, Indian Institute of Science, Bangalore, and is holding the Professor Satish Dhawan Chair Professor position since October 2018. Professor Nagesh is the chairman of the Center for Earth Sciences IISc since March 2014 and is also an associate faculty in the Interdisciplinary Center for Water Research and Divecha Center for Climate Change of IISc. He is the editor-in-chief of H2 Open Journal by IWA Publishing UK, associate editor for ASCE Journal of Hydrologic Engineering and ISH Journal of Hydraulic Engineering. He received the Best Associate Editor Award for ASCE Journal of Hydraulic Engineering for the year 2014. He has been a reviewer for more than 75 international journals and has published more than 200 papers in leading international journals and conferences in research fields. He has co-authored 6 textbooks, Multi-Criterion Analysis in Engineering and Management, published by PHI New Delhi, and Floods in Changing Climate, Hydrologic Modeling, published by Cambridge University Press, UK, Impact of Climate Change on Water Resources, published by Springer, Germany, and 3 more. Professor Nagesh is a fellow of the Institution of Engineers and the Indian Society for Hydraulics. He is a member of AGU, IAHR, ASCE, IAHS, ISMCDM, and Indian Society of Remote Sensing, and acknowledged with IBM Faculty Award for the year 2012 for his outstanding research in the field of modeling hydrologic extremes using microwave remote sensing. His research interests include climate hydrology, water research systems, climate change, impact on water resources, ANN, evolutionary algorithms, fuzzy logic, MCDM, and remote sensing, and GIS application in water resources engineering. Now, I would like to invite Professor Nagesh Kumar Garu to hand over the session.
Thank you. You need a glass of water now. Your introduction is so elaborate. Thank you very much for that. Can you please confirm that you can see the slide?
Yes, sir. Yes, sir. It is visible, sir. Please proceed, sir.
Thank you. Yeah. So first of all, let me congratulate Girish and his team. Sorry, I call him Girish, Professor Girish and his team for doing this event, which is not very easy, especially in this pandemic situation, on a very important topic of sustainability in civil engineering, because it's the way civil engineers can either make the whole world sustainable or unsustainable based on how we actually propose to improve the lifestyle for our civilians. So we make a big impact, and to make sure that most of the things that we are doing are actually sustainable, this conference is really timely, and I really appreciate the effort that's put in by Professor Girish and his team to make this event happen. Especially, I mean, I'm not counting myself in that, but I'm seeing that there is a galaxy of good keynote speakers, and that itself will be a huge value addition for all the participants. What I would like to do now is I'll briefly talk about some of the very useful tools like remote sensing, GIS, and DEM for flood inundation modeling. Because I know you, Girish, very closely, without any hesitation, tell me when it is 5 minutes before my talk.
Sure, sir. Sure, sir.
Okay? Because that's very important, and I don't want to cross the schedule. So what we will try to do is we'll briefly talk about these 3 tools and how we can try to utilize them for flood inundation modeling. Even before I go into the details of it, let me first of all mention what I am trying to aim at through these 3 tools. You know, all of you in hydrology are aware when we talk about flood frequency analysis. Means what we have done is that for every year, we try to estimate what is the maximum flood event that has occurred, what is its magnitude, say in terms of volume or in terms of discharge, and call that as the maximum flood event for that year. Like that, we do it for every year, say for about 40 or 50 years. And if we have the data, using that data, we try to do some simple statistical analysis like Gumbel distribution or something like that, and try to come out with what is the frequency of a given flood magnitude. So if I say that, this is a 60-year flood, what we mean, that means that magnitude event will happen once in 60 years. That is simply based on, putting all these flood events in ascending order and try to find out simply m by t or m by t plus 1 or something like that. Okay, and that gives us not only for the duration of the data for which we have the data, say for about 50 years, but we can extend that logic or extend that graph to flood frequency analysis graph to talk about what happens, what is a 100-year flood. We did not wait for 100 years to observe data to get that, but we can project it. In the same, what is a 200-year flood or what is a 70-year flood? Those magnitudes, we can get it from that flood frequency analysis. But what I wish to do now is that corresponding to that magnitude of that flood event, I want to prepare the corresponding flood inundation map. So that, if you tell me that in 60 years, I'm going to get a flood of magnitude ZZZ, okay, then corresponding to that magnitude, I'll provide a map. So you not only know the magnitude, but you also know in which locations that flood will be occurring within the river basin or within an urban area. That's the ultimate aim of this talk. Okay. How do we do that? Simple concept. If you remember the concept of tan theta is what? Tan theta is, opposite side by adjacent side. Or you can say slope. Slope is nothing but the elevation difference by distance, right? That's the simplest concept. Tan theta concept is what I require to do this whole work. Okay, but before I get into that, let me briefly talk about what we mean by how we can try to use these tools, remote sensing, GIS, and DEM. We can talk about floods and their potential use of then we can talk about real-time monitoring of floods, GIS for flood damage assessment, delineation of flood-prone areas using modified topographic index, or especially for Mahanadi Basin, I'll try to demonstrate that. And based on that, I try to conclude. Okay. So, as we know, floods are most common and widespread of all natural disasters. And floods cause damages to houses, industries, public utilities, and property, resulting in huge economic losses apart from loss of lives and habitat. Though it's not possible to control the flood disaster totally, but by adopting suitable structural and non-structural measures, the flood damage can be minimized. Structural measures, we try to construct a flood banks or levees, dams, barrages, etc. to control the floods. They are all structural measures. Non-structural measures means if you already have a structure and you can try to close the gates of a dam so that the flood waters are impounded in the reservoir, and downstream there is no impact of that flood. Okay, such measures, non-structural measures, both can be done. But for planning any flood management measure, latest, reliable, accurate, and timely information of the flood is required. Remote sensing technology has made substantial contribution in every aspect of flood disaster management, such as preparedness, prevention, and relief. I'll briefly mention about them. So remote sensing can play a role in flood management in various aspects, starting from flood inundation mapping and monitoring. That is the easiest aspect. Then rapid and scientific based damage assessment. For that, we have to use GIS along with remote sensing. Monitoring and mapping of flood control works. If you already have, let's say, a levee, is it working? Flood bank, is it working? Is it breaching somewhere? Is there any potential location? Monitoring and mapping of changes in the river course, like river meandering, can be monitored. Identification of riverbank erosion which may finally result in breach of a bank or canal or a river. Okay. Identification of chronic flood-prone areas, inputs for flood forecasting and warning models. In all these things, remote sensing plays an important role. Once a flood event occurs, what we try to do is we try to get an image or satellite image or aerial image of that location as quickly as possible. Okay, and that gives us an idea about the amount of inundation. And satellite remote sensing provides synoptic view of the flood affected areas at very frequent intervals for assessing progression, recession of the flood inundation in the short span of time, which can be used for planning and organizing the relief operations very, very effectively. You know, if you are talking about any operation or relief work, first of all, you should know where you should go and do the relief operations. And for that, these maps or these images will help us a lot. Just to give you an idea, you know, what you are seeing here is an image that is obtained from Indian Remote Sensing Satellite P6 AVIFS or Advanced Wide Field Scanner image. Okay, it is showing here a large portion of a river when the flood is taking place. Okay, and trust me or train your eyes for some time. What you are seeing in red color here on this image is all healthy vegetation, because what I am showing you is called standard false color composite. Okay, and then you can see a lot of water body and a lot of flood water is spread here. Okay, and you can also see lots of black patches. These are all actually moist lands, means fully saturated soil. Okay, therefore, if any more rain occurs here, that will be contributing to the flood. If it is a dry land, you know, some portion will go as infiltration because the soil is already moist, saturated, because all the water will flow as flood flow. Okay. So that's one major advantage. You know, in synoptic view, entire reach of the flood zone can be monitored. And you know, if you know what is a pixel and what is the size of pixel, for example, pixel on the ground is representing, let us say, 100 meters by 100 meters. That means if you count how many number of pixels are there in the flood water, multiply by 10 power 4 square meters, 100 into 100. Okay, you know what is the total area under floods, right? And then we can also know the places where there is a potential flood that is likely to take place if the rainfall continues. Okay, so that's one thing that we can do very easily with the help of remote sensing, synoptic view. But only problem then is these white patches that you are seeing here. You know, these white patches are actually cloud. Typically, when flood is occurring, it may be because of heavy rain. And if there is a heavy rain, it may be because of lots of clouds. And when the clouds are there and the satellite is above the clouds, okay, most of the optical data, you will not be able to see anything below the clouds. So we don't know whether the portion below the cloud is flood inundated or it is simply having no effect of the flood. We will not know. Okay, that's a problem with the cloud cover. And this problem can be overcome if we try to do the remote sensing in a microwave remote sensing or microwave spectral region. The main advantage for microwave is that microwave will simply penetrate through the cloud. So the cloud is transparent to the microwave. Therefore, it can see what is there below the cloud. And you know, when compared to this kind of image that I'm trying to show, now if you try to use, let's say, synthetic aperture radar microwave, okay, then you can overcome this problem. And you know, I'm now trying to show you a picture of Assam state where Brahmaputra river is very popular river, but it's also notorious for floods. Okay, so you can see the river course, you can see the inundation zone where the flood is happening, and you don't see one cloud cover. Okay, entire image there is not even cloud cover. This is not just one image also. You know, this portion is one image, and this portion is another image, and there are three images put together to create this map. Okay, and this is actually using RadarSat mosaic of 2 days, 4th and 7th July 2003. Okay, for the entire Brahmaputra region, because it is radar data or microwave data, we are not seeing any cloud cover. So we can identify every location and see whether that point is flooded or not. Every pixel by pixel, we can estimate that. Now that's one major advantage as far as remote sensing is concerned. But let us say that we have prepared this kind of flood map, or we have prepared this kind of flood map using remote sensing. But then we need to know what is there below in this location. Is it a village, or is it a agricultural land, or is it a forest area, or is it simply barren soil? Depending on that, you have to worry about the damage that is happening in that location. For that, what we try to do is that we try to use geographic information system. GIS basically helps in flood monitoring and assessment in various ways. First of all, collate, prepare different maps. For example, you have village map, or you have a district map, or a state map. Okay, so those maps, you try to digitize them using GIS platform, scan it and try to geocode them. Then therefore you will have all those maps available to you. Okay, so collection and processing of the data is the first thing that we try to do, and create this database and keep it ready. You don't start doing it when the flood is happening. You have done it much before. All these maps are prepared and kept ready. What are the villages? What are the boundaries for those villages? Where are the agricultural land? Where is the forest land? Where is the railway line? Where is the road line, canal line, river line? Many things. Okay, all those maps are prepared as multiple layers and kept ready. Okay, they're all for the same region. Therefore, they can sit one over the other in transparent maps. And that's what we try to do through GIS. Then we can try to extract technical information. How many villages are there in a district? What is their total area? Or how much is the total length of roads in that district or in that state? Okay, such information can be extracted. And we can try to put that layers also. And let's say that I want to see how many villages are there very close to the river, or at a distance of about half a kilometer from the river reach. Map all those villages. That's a query that you are asking in GIS. It can use the layers of information, that is a river map and the village map and the village boundary map. Okay, based on that, it can prepare that map and show it. So query-based analysis can be done, and that is what is called as knowledge extraction from GIS. So GIS basically will have three stages: database creation, technical information, and knowledge extraction or visualization. In all these places, GIS plays a very important role. So let us see how remote sensing and GIS can together be used now. Let us say that from remote sensing, we have prepared a flood layer, flood map. Okay, and from our earlier GIS databases, we have village map, we have agricultural map, forest cover map, etc. Rail network map, road network map. So now what happens? If I try to put flood layer map over village map, then I can talk about the villages maroon. Count pixel by pixel, I can count them and say how many villages are maroon to what extent. Entire village is maroon, or only portion of the village is maroon. If only portion of the village is maroon, then we can try to put all the other villages, or move all the villages from that marooned area, are likely to be marooned area, to the non-maroon or non-flooded area within that village. So you have that cyclone shelters or flood relief shelters, etc. based on that. In the same way, how much is agricultural area marooned? Rail network. So where do you want to stop the trains because of the floods? Road network. All this can be done with remote sensing is this portion and GIS is this portion. Then the next that I want to use is DEM, or digital elevation model, which you have done in your surveying class also. You take a dumpy level or a total station and try to get the elevation data using that dumpy level or total station, using staff gaze and other things. Let us say what you do now when you note down in surveying, you not only note down the elevation, but you also note down the location where you are getting that elevation, XY coordinates, or latitude and longitude. So if you give me the XY coordinates and the elevation at a given location, and if you store it on a computer database, it becomes digital elevation data. If you want to play around with it, it becomes digital elevation modeling. So that's what we try to do now, apart from remote sensing and GIS. So if I know the elevation, and if we also know the distance tan theta, that gives you the slope. Okay, so that's the simplest concept that I want to use now. Okay, so this is basically what you are seeing on the left hand side is basically, for a given X and Y coordinate, what is the elevation, the Z coordinate. This is what we try to do through surveying by dividing the entire region into small grid boxes and get the elevation information. This can also be done through satellites or space shuttles or aircraft. Getting the elevation information using different techniques, stereoscopic view, radar interferometry, and many other approaches. Okay, and once you get this, then we can try to draw smooth lines like this to visualize the three-dimensional surface. Okay, where there's a peak here, there's a valley here, etc. But the basic concept that I want is very simple, tan theta. Okay, let us try to use that simple concept and try to utilize it to talk about what we call as topographic index. So what I want is that elevation. First of all, elevation, we'll talk about if I know the water surface elevation and if I know the ground elevation, I know what is the depth of water. Pixel by pixel. In one pixel, if water surface elevation is, let us say, 5 meters. With respect to mean sea level, let us say it is 105. Okay, and the ground elevation at that location is 100 meters. Then the depth of water is 5 meters. Like that, I can do it for every pixel. So I can know the depth of inundation in every location. Whereas satellite image will tell you only the standing water. What is the depth will be known through D. Okay, and once the depth is known, where that water will flow will be known through slope. And slope will be known based on the tan theta. I want that tan theta now. So what we will do now, using the concept of tan theta, there is a topographic index that is proposed here, right? KB. Okay, it's simple thing. Log of AD divided by tan beta. Tan beta is nothing but the local slope. Local slope can be obtained through the DEM. Okay, and AD is the drained area per unit contour length. When you did surveying, your next thing what you will do, you'll try to plot the contours. Contours are basically lines joining the points of equal elevation, is it not? So using the area between two contours and the local slope between those two contours, we try to use the topographic index. And this topographic index is slightly modified afterwards by Manfreda. Okay. The only thing is, in the previous equation and this equation is that there is a power here, an exponent component here, n. Okay. And because of that, this becomes a lot more effective when compared to this topographic index. So if this is called topographic index, this is called modified topographic index. So using this, we try to measure the topographic index for every pixel, for every point where we know the elevation data. Okay, using that, we try to estimate the topographic index. Once we estimate that, then we try to say, okay, if the topographic index is above this point, above this threshold, it may be, let's say, in the range of 0 to 1. Okay, if it is above 0.9, I call that as a flood inundated location. And if it is below 0.9, it is non-flooded pixel. Like that, I try to do it for every pixel in the entire river basin. What is the threshold? I don't know. So what we will do is that, let us say for a given flood magnitude, we already have the flood map available from National Remote Sensing Center or somewhere. Okay, I know the magnitude. I also have the map. So now I try to play around with this threshold in such a way that the map that I generate will match with the map that is already observed. Once those two match, then I say this is the threshold that I should use for this flood magnitude. I do it for about 3 or 4 or 10 number of events like that. Then what I am doing for every flood magnitude, I know what is the threshold that I should use to prepare the flood inundation map. I do it over a few iterations for a few number of observed maps. Then I can prepare large number of thresholds for different flood magnitudes. That is what is, yeah. I know. 5 minutes. So we try to prepare different thresholds and try to match with the flood inundation map. There could be 2 errors, error of omission, error of commission. These are called ER1 and ER2. So that's what is estimated for different thresholds for Mahanadi River Basin. Okay, and we try to look at this entire river basin, and we try to use different DEM databases from ASTER DEM, SRTM DEM, GMTED, etc. And from each spatial resolution of the DEM, we prepared the flood inundation map. This is the original map, DEM data that we have used. Okay, and based on the observed data that is available from NRSC. Okay, these are the three maps for three different flood magnitudes occurring in 2006, 2008, and 2011. The blue portion that you are seeing are the flooded locations. Okay, and we prepared them for various thresholds using modified topographic index, using this particular flowchart. Play around or try to run it for multiple iterations. Okay, and then when it matches, we try to see what is the minimized error. And for various spatial resolutions of the DEM, we try to prepare the flood inundation maps and try to see which DEM is doing better. We found that among all the DEM databases that we used, SRTM DEM is doing very well. So we use that DEM to prepare flood inundation maps. I have shown it to you for 3 events, okay? And those 3 events maps are shown now. These are prepared from DEM data using modified topographic index, okay, for 2008, 2011, and so on. Now we have different thresholds for different magnitudes. So give me any flood magnitude. I'll tell you what could be the threshold value you should use. Use the threshold value, prepare the flood inundation map. Okay, that's what you can do by integrating remote sensing, GIS, and DEM, and talk about preparation of flood inundation maps. That's the main advantage. You can not only talk about the magnitude, but you can also talk about the map corresponding to that magnitude. That's what I want to conclude as far as this particular topic is concerned. And if there is time, I can take questions. Otherwise, you can always send me a communication to me, or you can refer to this paper based on which I presented this work. This is an MTech student's work. Apurva, she was my former student.
Thank you.
This back to you.
Yeah, thank you very much, sir. Sir, we have 2 minutes. If you have any questions from the participants, then we can take.
Sure, I'll be happy to do that.
Yeah. I request the participants, we have a couple of minutes, 2 minutes for this discussion. If at all any other queries do you have, please, you can go ahead with asking questions or posting in the chat.
Maybe it will take some time to digest. I was too fast.
I have disturbed only because you said me to remind you, sir. Basically, I don't want to disturb.
I know it's very important because when you have organizing such an event, everyone should stick to the time. That's very, very important.
It's okay, sir. Then okay, sir, we'll move to the next session, sir. So thank you very much for the acceptance, sir. I always oblige to your words and your support and encouragement.
I wish you all the best for the grand success of the conference.
Happy Dasara to you, sir.
Thank you. Happy Dasara to all of you. Bye-bye.
Yeah. Bye, sir. Thank you, sir. Yeah, we'll go with the proceedings. Yeah. Krishna?
Thank you, sir, for sharing your valuable information with us. Your talk has worked as a starting point to resolve important issues in this area, and this inspired many of us to take individual initiative. Now, let us have our next keynote talk on advancement in roadway technologies. Innovative materials, best constructive practices, and asset management by our next eminent speaker, Professor B. Krishna Prapurna Garu. Professor Krishna Prapurna has obtained both doctoral and Master of Science degrees in Civil and Environmental Engineering from Arizona State University, USA. He holds a Bachelor of Engineering degree in Civil Engineering from Visvesvaraya Technological University. Professor Prapurna is currently positioned as Associate Professor and Head of the Department of Civil and Environmental Engineering at the Indian Institute of Technology, Tirupati, India. He is associated with various international societies such as US-based National Academies of Engineering, the American Society for Testing and Materials, and Recycled Asphalt Foundation, etc. Professor Prapurna also serves as Associate Editor of the Elsevier's Resource Conservation Conservation and Recycling Journal, Associate Editor of American Society of Civil Engineers, Journal of Materials in Civil Engineering, Associate Editor of Taylor and Frankie's International Journal of Road Materials and Pavement Design, Editorial Board Member of American Society for Testing and Materials, International Journal of Testing and Evaluation, Editorial Board Member of Springer's Nature, International Journal of Pavement Research and Technology, Associate Editor of Springer Nature's Innovative Infrastructure Solutions. He is a lifetime member and Executive Fellow of International Road Federation. He is also a recipient of Young Scientist Award from the Board of International Institute of Noise Control Engineering. In 2015 and 2018, he was awarded the Asphalt Rubber Ambassadorship for the Republic of India, instituted by Rubber Payments Association and Asphalt Rubber International Conference Group. He has authored, co-authored and contributed over 190 papers in scholastic journals and peer-reviewed international conference and over 60 report, press articles, newsletters and guides to date. During the last several years, he has been advising, mentoring several scientists, undergraduate, graduate student, researchers and practitioners. His research and teaching experience include transportation pavement materials, design, maintenance and rehabilitation, highway noise evaluation and modeling, sustainable and smart infrastructures. Finally, I oblige my gratefulness and gratitude for accepting our invitation and request you to take over the session, sir. Thank you, sir.
Sir, hello, sir. Good morning, sir.
Can you hear me?
Yes, sir. Now it's fine, sir.
Yeah.
Yes.
Yeah. Okay. Very good. Thank you. Thank you for the introduction. Okay, let me start sharing the screen. Let's see. From the tray, correct?
Yes, sir.
Working. I don't know. I think I need to be made the host, maybe.
No need, sir. No need, sir. Just
okay.
Sharing is available for everyone, sir.
Oh,
We
okay.
give the option. Yeah.
Can you see now?
Sir, I am unable to. Oh, yes, sir. It's sharing. Yes, done, sir. Done, sir.
I just will switch off my video, so because bandwidth is an issue.
Sure, sir. Sure, sir.
Yeah. Okay,
Please give the full screen mode, sir.
Yeah, that's what I'm trying to do. Oh, there you go. Can you see now? Full screen?
Perfect, sir.
Okay. Yeah, very good.
Yes, sir.
Okay.
It's perfect, sir. Please.
Okay. Yeah, very good. Thank you very much once again, Girish, for inviting me. I think this is the third time I'm coming, right, to your
yes.
To the online lecture organized by your institution. Anyway, so I thought I'll give you some very brief. I should not say a lecture, but brief discussion on several things on roadway technologies, including materials design, and then innovation in the material properties, and also the material product development itself. Okay, and then the construction practices that that we think are good if you really need to have good pavements or good roads for the next 30-40 years. Apart from this, we also have been saying that just not building, but also the asset management is an important issue, because we have to also take care of our assets, otherwise they'll start to dwindle away, right? So it's important that we not only construct using good quality materials, but also manage them over the next few years until at least the design period, right? So this is what I thought, if you really look at the global perspective and what everyone is doing and what we also embark upon, okay, in the next few years, at least that is what the entire vision of the transport sector is right now. Okay, so we are collaborating. So it's a very important aspect. I start from the deep right here, not from the left, just to start from here, and then I'll go back. If you look at this is where we should be standing if you really want to have excellent technology transfer, or even start giving out our ideas to others and also implement it elsewhere. I think we should have excellent collaboration. It could be both national and international level. And we have had that. There are excellent centers of excellence in India. We look at the CRRI or some of the institutions that is there, right, in India itself. And then we have several research institutes, one of them being in Kerala. So Kerala Highway Research Institute is one. And then there is NATPAC. And of course, Samson Matthew was here, so he belongs to NATPAC as a director. So you have excellent institutions across the country. Apart from that, we are also building our own institute at IIT Tirupati, which I'll explain to you in the next coming slides. Okay, we have good collaborations with the ministry, and ministry has been supporting several sponsored research. Then we have the National Highways Authority of India, which is also doing a lot of work, not just implementation, but also the research side. I believe there are at least 20 to 30 projects across the country with several institutions. Then European Union has been in touch with India. And again, Indo-US plus the other centers. Okay, if you talk about European Union or South Africa, or for that matter, Singapore or Australia, they have had excellent collaboration. Now, coming back to the first one, okay, as I told you, we'll start from here, but then move on. So if you would really want to do some global innovations and that are sustainable, resilient, and dynamic in nature, right, you need to have excellent academic prowess coming from our students, and we need to have good education. Right? Capacity building measures is what we are talking about. And that will entail us to build good research centers. That's there. It's already there. And then industry participation. I always keep saying this. We need to have the industry come forward, ask for client-based approach. When we say that, we mean that they need to bring in some problems and we solve it from the academy. So that is how we build the model. And that is a very successful model across the world. Again, education and training, capacity building is what we are doing right now, also is part of the capacity building measures. We talk about the other areas which you people are familiar, so I'll just skip those, except for the fact that you need to be looking at a very holistic perspective if you're talking about roadway pavements, right? One is the materials, testing, and then we have the sustainability aspects where tire pavement noise, different materials that are coming into picture, rubber for that matter, plastic, right, wastes, textile, and so forth. And then coming to the environment, global climate change, that's the sustainable development goals. We talk about the life cycle assessment and many other aspects, right? And then finally, the fundamental science, which is what we are really looking at if we're talking about the equations that we develop, the fundamental models that will remain and will be probably calibrated every time we add new data, right? So data science, big data, analytics, all those things come into picture here, and we are looking at talking about the roadway pavements. We're looking at the mechanistic design, wherein we see the actual working of the road in the real field scenario, and that will be matched with the lab experiments that we are coming up with. Okay. Now, I'll just talk about 3 different modules which I thought are something that we have done recently, and also probably some of you can take it up as your research projects. Okay, not just the BTech, MTech, but also the PhD and also the other emerging faculty members. Okay, one of the things that we have developed, I actually gave a small lecture last time on pervious concrete, but I thought I'll also share with you the new things that we have done with this. Okay, coming back to the background, why we had to develop this pervious concrete is that it is a smart product, no doubt, but then there is a lot of changes coming up due to urbanization. One of them is the hydrological, the other is the temporal, the temperature effect. So if you look at the global climate change, right, there are a few places which were really warm previously, but now they are cooler. And some of them were cool in the past, but now they are warm. So what is happening? It's because of the urbanization. And as we all know, I think most of the people are migrating from the villages to the city side. Obviously, for several reasons, it could be socio-economic, it could be other reasons also, right? So if we talk about this surface runoff over time, that's what it's a classical plot that you see, right? And what we are looking at, if we talk about this right plot here, top, we are trying to construct or build the urban areas, but still be within the pre-urbanized setup. What does that mean? We are still in the sustainable regime, right? We build, but we make sure that the materials that we use or the products that we are developing, they're all sustainable, meaning there is not much change with hydrological and temperature, okay, in the surrounding environment. Now for that, what you should be doing is you need to have better recharge of the groundwater, right? And for that, you need to also have reduced runoff. So if it precipitates, as it is happening right now in many parts of the country, you make sure that it does not run off. So surface runoff will be minimized and increases the groundwater. recharge. Okay, and for that you will be needing definitely pervious natural ground. But can you have pervious natural ground in cities? Yes, of course you can. Instead of actually having fully impervious ground such as concrete, what you could do is to come up with some other solutions such as porous materials. Could be porous asphalt, porous concrete. Right? One of the things that we have done is the porous concrete, pervious concrete. They call it permeable concrete in some places. One thing that it can do, and it is a good strategy for stormwater management. As you can see here, you have a lot of water stagnation, urban flooding taking place, and that could be curbed. And there are a lot of, recently also in Bangalore, there was a lot of floods, and people could not go to the airport on time, and they had a lot of difficulties, right? Some of the solutions that we have developed, this is one of the strategies, okay? Now, 3 demonstration sections, I'll not go into the details of what is pervious concrete and how it was made, because they're all published articles, but what I thought I'll share with you are 3 or 4 different sections that we have built and what we did with that material, right? The first section was built in IIT Kharagpur way back in 2017, June. Okay, it still exists, but just clogged because of low maintenance. This is what happened, incessant rainfall, about 55 hours in July 2017, and you can see this is the only area which did not get inundated. And the second thing that we constructed was in Tirupati, that's Smart City Municipal Corporation of Tirupati premises. And it still exists, by the way. It's being used by cars, trucks, and so forth. Okay, it was built within a record time of 2.5 days, about 120-meter long stretch. Okay, and then on IIT Tirupati campus, we have built that. Also, if you happen to come, please visit us, and I'll show you. We have actually embedded pipes within the pavement section where you can read the, you can get that water out, retrieve it, and then use it for some other purpose. So the pipes are embedded within the pervious concrete, and we were successful in doing this. One of the other things that I should really mention here with IIT Tirupati is we tried RMC, ready mixed concrete, and that really worked out. I should say probably we are the first people in the country to use RMC for pervious concrete. We were very successful. Yeah, and we also use geotextile to have no tensile cracks coming from bottom. So you can see this is the final product. You see one side there is RMC that's fully consistent design there. On the other side we have the in situ mixer being used. So all the 3 different locations we have actually published those. Please visit the different journals and you can actually get the details of how it was constructed, how they were constructed, I should say, and how the mixed designs were performed, and how they are still performing over time. Okay. And the other thing, this is what I thought I should share with you. This is a new latest product, 2021. In fact, just a couple months ago, we had a PhD finishing up. So we have come up with a paver block, and this will be used on rural roads very soon because we have had collaboration with Kerala Highway Research Institute. And also, we're talking to National Rural Roads Development Agency to come up with some test sections with pervious concrete. We call that Parampave. As you recall, the pervious concrete, the ones that I just showed you, right? Some of the test sections, they're all low to medium volume roads. When we say that, they are low strengths because of very high porosity, so they cannot be used on highways. So we thought, okay, we will come up with new product that could be used not only low volume roads, but also in medium and also high volume, such as the highways, highway shoulders, medians, and so forth. So what we did, we have come up with a composite now. It's a square composite. You can see here 30 centimeters square. Okay, and we have 2 slits in the bottom that can actually drain water out, and we will actually have pervious concrete within those holes and also on top. So it's a composite section with 30 centimeters square. That's the block. It's a paver block basically. It's a 90 millimeter section. It's a thick 90 millimeter thick section with PCC layer as the base course. So that will act as the resting ground for the pervious concrete that will be placed on top of it. So it's a 30 millimeter section. So if you ask me the advantages, of course there are many, but I'll give you at least a couple of 3. One, it's a composite structure. It has a strong base, so that can be placed anywhere, all weather, all road. That is why we call it pervious, all road, all weather, multi-layered pavement. So it's called Parampave. Okay, and we have. We also have the other advantage of having this small section. There's a thin section that could be removed After every 3 years, if you really want to have maintenance done, you remove that and replace, right? And the other advantage is you can actually lift this. It's only about 15 kilograms. It's like a 3 or 4 year old baby that could be lifted. Okay, you wash it and replace it. That is what you can do with this. And this will be tried very soon. And this is the cost of each of the paver blocks. So we have conducted experiments on approximately 18 types of mixtures without sand and 18 with sand. So it's about 36 mixtures. And if you look at the mass of each of them, it's about 18 kilograms. So it's a baby, right? And versus the concrete paver block of similar size, similar dimension, okay, it's about 20. So you're lighter there with this material. Now coming to the cost by itself, right? You see here, talk about this total cost. It's about 5 rupees per block. Okay, that is what we are looking at. And there's a cost saving with our material. And also, if you look at 1 kilometer of road wastage, this is what we are discussing with our state, AP State Road Development Corporation, and also the National Rural Roads, where you can save approximately 2 lakh rupees per kilometer. Okay, if you look at the overall cost, including the labor, material, and so forth. Okay. What else we have done? We've also done some life cycle assessment. If you look at, if you recall what I told you in the beginning on the visions, right? One of the things that we really have to do is the life cycle analysis. Why? Because we have to be looking at the overall design life, make sure the product lasts for the entire design life, and also could be reused when the product has served its entire life. Okay. So if you look at the LCA framework, so we have the extraction, processing, development, use phase, and also the end of life. And one of the other things I just mentioned to you, can it be reused or will it become waste? Right? Even if it becomes waste, it should be reused somewhere. And that is what we have tried, and we have come up with this framework for our own, for our pervious concrete pavements, including the Param Pave that I just mentioned. It's a published document. You please visit this. It's a top journal in the environmental sustainability area. Okay, in fact of almost 10. So what we did, we have come up with a toolkit. It's an open source. If you wish, we can help you with this. Okay, and what we are trying to do here, we will calculate all of these: embodied energy, kg CO2 equivalent, and capital cost. And what we have approached is not the entire system, because we don't know when the pavement will fail or when the service life will get over. So what we have done is cradle to gate approach. That's until the construction and placement, okay, which is still not bad. And this framework could be used by any other material as well. It's not just about pavements, but also any other. So if you look at this, there is energy that's being input when you are producing the material, the mixing phase, we call it. And the other thing is the energy that comes out, that's the GHG, greenhouse gases, correct? So this is the product, and you have a functional unit of 1 kilometer. That's what we used. And for some others, you can use it, you can keep changing it, tweak it, depending on the situation that you have. 3.5 meter wide, so 1 lane road, okay, 35 centimeter thick section with 15 centimeter of pervious concrete and a 20 centimeter of a granular base course. Okay. And if you look at the results, okay, we had about 3% lower energy coming from our pervious concrete, which is something very encouraging for us. And what we have seen later on with Param Pave, this is with the regular pervious concrete. What we have seen with the Param Pave product is it's at least 7 to 10% lower LCA. Okay, so something very much encouraging for us, and we have tried this. And what we expect in the future is to also start calculating life cycle cost, because that is something that we have to do, includes maintenance, intervention, salvage, and many other things. Okay, so that's the big data we're talking about. Okay, the next product I thought I'll share with you, that's also very close to my heart over the last 17 years that we have been working on, is the asphalt rubber. Okay, rubber modification in binder. And what we have seen over the years, at least that I have seen, and my predecessors who have worked on this product for almost 40, 50 years now, they've seen that it's not just a durable product, but also it has a very low life cycle cost. Now, coming to the environmental perspective, definitely engineering use of old tires. How much? Approximately 15,000 tires per lane kilometer. That is what is the estimate coming from the global scenario. And what we have done, we have come up with a new generation product at IIT Tirupati. I'll share with you in just a minute. If you really want to understand what asphalt rubber is all about, please visit this website, rubberpavements.org. And there's a standard practice guide. It's open source, so you can download it free. Okay, there's no cost. And I'm one of the co-authors. It was, of course, 10 years ago, but still very much feasible. And where all we have used asphalt rubber in all kinds of layers. It could be base coats, it could be a binder, it could be a surface coats. It is also a product that is being used as a composite, as a friction course on top of a strong concrete base course. Okay, so as you see here, asphalt rubber friction course over PCC. And as I mentioned just now, 15,000 tires per lane kilometer. That is something that is very much environmental friendly. So if you don't burn these tires, that will be the best. Now, if you start reusing it elsewhere, it could be not just in asphalt, but also in concrete. So people have used rubber in concrete. We have used rubberized pervious concrete. We have prepared those mixtures, and it actually gives us additional 1 or 2 megapascal of strength. Okay, and one of the other things that I mentioned just now is the life cycle. As you can see here, it's asphalt versus Portland cement concrete versus asphalt rubber. You can see it's about 10,000 kg CO2 equivalent versus 20,000. It's about half kg CO2 emissions coming out of asphalt rubber because of the thin sections and also rubber being used. Okay, and if you look at the life cycle, it's still much way beyond the concrete and the regular conventional asphalt. It's a published document, please visit. Now, the new generation product that we have developed, okay, we call it MargPave, Modified Asphalt Rubber Green Pavement. It's one of the PhD products just a couple months ago that we finished. Okay, and it is now a semi-dry process. We call it, I would say, dry mixing. Okay. Why we call it dry mixing? Because people have always said we use rubber with asphalt binder, and that actually emits a lot of fumes at very high temperatures of mixing and compaction, approximately 190 to 200 Celsius, right? And what we can do with our new product is it could be used as a patching material, pothole patching, and we'll be trying this very soon. And we have our collaboration with Petroleum Conservation Research Association, where we will be encapsulating these rubber products. And could be used straightforward in the pug mill. When I say pug mill, you have a MAR product, that's our modified asphalt rubber. Okay, it's a powdered form, straightforward, put it in the pug mill. It's like a fiber. You use binder separately and the aggregate. So now you mix it as a dry process. So basically, you don't need any sophisticated equipment for this. And it's very quick, and you can use it as a pothole patching material. Okay, and as I told you, no need for expensive equipment. So if there are industry people in this conference, please approach us. We will help you out with this. Well, we are now in discussion with Petroleum Conservation Research Association, especially with the consortium of Indian Oil Corporation and Bharat Petroleum. Okay. The last thing I thought I'll share with you, another 5 minutes I'll take without taking much time, okay, is the pavement asset management. As I mentioned to you, best construction practices and the materials. Apart from that, we also have to manage our assets. How do you do that? We know for a fact that pavements will deteriorate over time. Similar to us, they also age, right? If you don't take care of them, they will have premature failure, such as cracking, potholes, you name it, it's there. Okay, so you have to address those, and you have to have the maintenance interventions taking place. That's important. Okay, and as you see here, one of the plots is a classical plot. So it's a pavement condition versus pavement age. So over time, the material deteriorates of this nature. Okay, and if you have to maintain those assets, you'll have to do either preventive maintenance or corrective, or even probably a major rehabilitation to bring back the condition of the pavement as it was during the first day of construction. Okay, now how do you do that? So you have a PAMS, pavement asset management system, and what we have done in the last 4 years we have worked with APE. State Road Development Corporation, and they've given us data for the entire state, almost 1.4 million data points, or 14-15 lakh data points that we have. We have used that data to come up with prioritization optimization. So we have created our PAMS for the state, which includes about 5 or 6 modules, which also includes prediction, detection, analysis, and rehabilitation. Okay, we haven't gone into the cost, which will be our next step, obviously. But for now, we have done this. And so here is a picture of the network survey vehicle that's available. And the data was collected using this. You can see our group here. In fact, we recently graduated one PhD from IIT Tirupati. She's the first PhD of IIT Tirupati, graduating in August. Okay. So we have come up with these modules. One is, as I mentioned to you, pothole detection, multi-distance detection, come up with engineering criteria based UPHI, that's Unified Pavement Health Index, and then also delineation approach. 4 or 5 modules that we have come up with. And I'll just take you through, okay, very briefly. So one of the things that was published in a proceeding, International Conference on Maintenance and Rehabilitation on the pothole detection, quantification, and maintenance. So you have a pothole, we will be able to detect with our algorithm. We can come up with the amount of material required for patching, right? So it's a twofold approach there. The second thing is the multi-distress. So we are able to detect about 18 distresses with our module using YOLO architecture. You only look once, version 4. And it's a published document again in the Transportation Research Record. So journal, international journal there. Please visit this website and download. Again, final slide, which I thought I'll share with you is what do you expect with all of these? Is we definitely have to continue monitoring our pavements. Noise.
Yes, sir. Please proceed. Sir.
Yeah.
Sorry, sir.
Yeah,
Yes,
yeah.
sir.
Okay. Yeah, no problem. Okay. So what we have to be doing now is to build some test sections, and that's what we are doing now with NHAI. So one project that we have with the National Highways Authority of India is to come up with amendments to the existing IRC 37 flexible pavement design guidelines. And we have about 200 kilometer of roadway stretch, which will be used for instrumentation and monitoring. That's what we are doing. So, and it's part of the long-term pavement performance. We are also in discussion with Ministry to build some test sections, Ministry of Road Transport and Highways. Okay, and also come up with the advanced tools. We have done that a little bit with AI, artificial intelligence, machine learning, and so forth. We have come with the pavement asset management. We will proceed further to come up with the cost considerations, right? And finally, what we should be doing is to establish that mechanistic design. How do we do that? You have to have that lab to field correlations of very high order. And finally, foster collaboration between academia and industry. As I keep saying every time, we need to have this industry coming forward and academia also go forward to help the industry solve several burning issues that are there. As you can see here, one video where you have the water percolating into the pervious concrete pipes, the rings, and then you can use that water elsewhere. Okay. Just thought I'll share with you our laboratory facilities. We have, so as department head, I also have the duty to tell you that we have 6 streams within civil and environmental engineering at IIT Tirupati. Please feel free to visit our lab facilities, more than 5,000 square feet. We'll be expanding it to about 10,000 square feet within the next 6 months, more than about 25-30 crore worth of equipment that we have. All of them state of the art. So it was built within a record time of 10 months for a new IIT, for a new institution. Okay, and we have, if we talk about just pavements, we have, okay, please visit this website whenever you have time. Okay, we have fundamental research going on, binder aggregates and mixtures. We have advanced research with excellent equipment. In fact, this is the best equipment that's there doing both asphalt and concrete pavement testing. One of the best equipment in the world, I should say, world-class DTS 30. And then the ongoing research that within our group, we have NHAI collaboration, we have KHRI, Kerala Highway Research Institute, we have APRDC, Road Development Corporation of the state, Petroleum Conservation Research Association. And then recently we got a 13 crore project from Ministry of Road Transport and Highways. So we'll be building a national facility for accelerated testing of pavements. A circular facility, as you can see here. It's a regular pavement section built over 50 meter by 50 meter land space. So please feel free to come in the next 1 year. We'll be commissioning it. The minister, Honorable Minister, will be here for inauguration. And then we have projects with DST. IIT Tirupati is working with DST also on tire pavement interaction ways. So several of my colleagues, thanks to them, I've been working with US, Europe. Then I was at IIT Kharagpur, and then IIC Bangalore, and also now at IIT Tirupati. So please visit our website and feel free to contact me for anything. That's all I have.
Thank you very much, sir. Thank you.
Yeah, I can take up some questions if you wish.
Good morning, sir. This is Dr. Sridhar. I'm working as a associate professor in civil engineering department, Sri Vishnu Engineering College for Women.
Sure.
I would like to ask one question, sir.
Sure.
In the previous slide, you have shown image processing, whether it is a satellite image processing or any picture you have taken on the ground.
That's correct. Yeah, it's a picture that was taken by NSV, Network Survey Vehicle. So the APRDC, they conducted survey across about 50,000